Is it presentation? Presentation. Awesome. So you're presenting right here. Okay. This is. Okay. See. No man, you know, I want to go back to work and anything more right than even 6. The boy, why exactly? Hey, so that's fun.
So what's the rest here? Diane, you're here? Zana, Curleen?
Yes, I'm here.
Oh.
Yes, I'm there.
Okay, I did not realize that. I'm just here wondering where you all were. I'm here where who wants to start or you're sending in the mail. All right, so Ricardo's gonna start, but he's sending out some mails to you guys right now, okay? Yes, Zana, you want to say something?
I said okay, all right. I said okay.
Zana, I see that you start looking out pretty up, aren't we? What's happening? You start dressing up, man. Not no more rugged in bed. Zana? Are you hearing me?
Mrs. McCarthy?
I can hardly hear. I'm not here.
Okay, I can hear you now. I'm hearing you. Actually, I'm at school still.
Oh, okay, that explains a lot. You're no more rugged in bed, eh? So you're actually all dressed up and stuff. So yeah.
Yes.
A lot.
Oh yes.
I think Curleen is trying to talk to me, but I'm not hearing her. Curleen, are you trying to talk to me?
Okay, yes, I'm trying to talk to you. I'm at my school now, and I don't have the audience. Like, I'm not at the UE Center like yesterday.
Mm-hmm.
So I could go about doing this. I have about 3 teachers here who would be able to be my students.
Okay, so do you want to go now then, so that the teachers can leave, or what do you want to do? Tell me. It's your option. It's your choice.
I'll go second. I'll go second.
Go after Ricardo?
Yes.
All right. Let me allow you to go first. Provide Ricardo's probably.
I'm actually just. I have to try to adjust my computer and everything. I'm just setting up in a classroom.
So I'll give you 5 minutes.
Okay. All right.
Okay. Let's give her 5 minutes and allow her to start. So Ricardo, at least you'll have more persons to do this. Huh?
1, 2, 3.
And then I have David.
4.
Who else am I missing?
Person from overseas.
Woman, who else am I missing? I know Curly did not go. No, it's not overseas. Ingrid didn't go. It's 5 persons I have. 1, 2, 3. Yeah, Ingrid didn't go. She's the only one from overseas that didn't go. So I'm gonna allow her to go, and then you all can go. I think Ingrid must come because she didn't. All right, so I'm giving you 5 minutes, Carly, to set up. Then we can start.
There's I'm not marking. Other things are from marking here. And I just married lesson from the kitchen. Yes. Yes. You are better between the MN program structure. Masters in Foundation. These are fine. Yes, I'm just like September. Oh, it's not up for the September, is it?
No, I think in March. What's the tomorrow?
I'm fine.
Next month.
It's one year? Yes. It's hard to know because they have many courses. You have to be on full-time student. Yeah. Also, outside of town. Well, you have to start math course. But then you keep affording it. At least, I think it always becomes like a research account. And I don't feel it, but I would recommend the her. But the math course, I think it's a math curriculum, research and math education, you have math application. What is it? Alright, so I'm gonna ask you to start. Carlene, are you now ready?
Yeah.
Carlene? Carlene, are you now ready?
One more minute, please.
All right, let me know when you're ready to start, okay?
Okay, I'll do so. Shortly.
No, that's the extra 3 minutes. These countries really
I don't know why.
I did not know
Yeah.
it's pretty good.
Oh, yes. Yes.
That's the reason.
Nothing to investigate. The person I said it was
Yeah.
not nice, but then the second one was the whole time. I still been.
Yeah. But how do you get search for And then I do it on your feet. Sometimes I try to watch it and show you. So you're going to another place? Yeah, I went to teach English. She was here.
Okay, ready to go? All right. I give it another minute.
On the last times that you changed
What's this? Your sense
Seriously. This one. And then that's something like that. I think maybe that eye because I'm using computer too much. This eye starts to be really. So maybe it's a strain. Yes. But
Mrs. Kirby?
It's ready.
Hello?
Hi. Are you ready now, Carlene?
Yes, I have to be.
Okay, you have to. All right, we're ready now. Ingrid, all is well? All right, so we're gonna go. Are we all there? Anya, Zana, Diane?
Yes, I'm ready. I'm there.
All right, so we're now going to start. All right, so you can go ahead and start. So I'm gonna turn this to me so I can see what is happening. All right, so you know how to share your screen and all of that, Carlene?
Okay.
Okay.
Hi, Mrs. Kirby.
Yes, Carlene?
I'm supposed to have a PowerPoint on the screen to show because that's not what I'm doing. I'm just teaching using the board and stuff.
No, that's fine. If that's what you're doing, that's fine. But is the camera, so can you put it close to the board so that we can see the board?
Okay, yes, yes.
All right, good. We're fine. That's fine.
Okay.
We're ready when you are, Carlene.
No, it's okay.
Should I just go ahead or are you seeing me?
Yes, I'm seeing you, and we're all ready and waiting.
Guess you'd like this.
You can turn it.
You want the entire monitor?
Yes, you can turn it down.
Okay.
I guess she wants to.
I guess so. All right.
For the past week, we have been studying relations, functions, and graphs. Today, we are going to learn about direct variation, also known as direct proportion. When we say direct variation or direct proportion, we're really talking about how one number changes relative to another. Right? How one number changes relative to a number. Let's turn our attention to this chart on the wall. Okay, we're looking at a toddler.
Yes.
I know I'm not a good artist, but this is a toddler. So we're looking at a toddler over time. As the toddler ages, under normal circumstances, the toddler will also grow. So they will increase in height. So most times you will not see a 3-year-old child the same height as a 1-year-old child, right? So as the child ages, the height also increases. All right? Do you understand that? Have you noticed that?
Yes.
Yes.
Okay, so today we are going to also, in addition to looking at it on the graph, just for you to see how it really happens, how to track it, how to look at it in a pictorial form. We're also going to use some graph sheets. Does everybody have graph sheets today? Okay. All right, so for those of you who do not have graph sheets, remember we also have a stock of graph sheets that we sell at $2 for one. Okay, so who would like, the person who do not have graph sheet and would like to get graph sheet, we do so now. How many graph sheets would you like? Okay, one graph sheet. One graph sheet is $2, right? Okay, so we have one graph sheet for you. $2. And
so if somebody say if he buys one graph for $2 and want to actually give you $4.
Right, so two graph sheets would be $4. Right? So as the number of graph sheets increases, the cost of the graph sheet will increase also. Alright, so you have two graph sheets, that is $4. Okay. There we go. All right, so in a short while, we are going to use the graph sheets. Okay? We're going to be using the graph sheet in a short while. Right? So we say as something direct proportion, as one number changes, the other one will change also. So if there's an increase like the graph sheet, when we purchase one graph sheet, we pay $2. If we purchase more graph sheets, two graph sheets, we would pay $4. Right? If we were to purchase 3 graph sheets, we would pay $6. Right? So it either increases as one number increases, the other increases. And the reverse is also true. As one decreases, the other one also decreases. Right? So for example, buy 3 graph sheets for $6, if you were to buy 2 graph sheets, you would pay $4. So the cost will go down, right? So when we speak about direct proportion or direct variation, we are saying that one number changes relative to another. Either it increase, if one increases, the other one also increases. If one decreases, the other one also decreases. All right? Now, we can write this in the form of an equation. We're already accustomed to doing equations, right? So, we're going to look at everyday situations and see how you can understand that. We're going to put it in the form of an equation. When we say something is directly proportional, we also have a symbol that we use for that, right? We also have a symbol, and you're going to learn what that symbol is today. So let us look at how we can put that in an expression. We can express that in the form of an equation. So we say, if we say the number of years increases is proportional to the height of the child, we would say y is proportional to x, right? Y would represent the height of the child and x would represent the age of the child. So as the child ages, the height of the child increases. So that is the height of the child is proportional to the age of the child. Right? So this is the symbol that we use for proportion. Okay? Do you understand?
Yes.
Okay. Okay. Now, we say one number increases, the other also increase, and when one decreases, the other one decreases. Now, when we say one number is proportional to the other, it means therefore that as one changes, the other one is going to change by what we call a constant, something that does not change. So using the example of the graph sheets, we can say that the number of graph sheet purchased increase, the total cost of the graph sheet also increase. But exactly what did not change in that scenario? When you think of something that did not change, the number of graph sheets purchased changed, the total cost of the graph sheets also changed. Is there
The price
anything?
of one graph sheet.
The price of one graph sheet did not change. Very good. All right? That price of the graph sheet that did not change, we refer to that as a constant. Right? So the constant remains. Constant means that something remains, it does not change. All right? Okay, so the constant in that case was the price of the graph sheet. So we are going to now look at how we express that formula, the y is proportional to x, or the price of the total cost of the graph sheet is proportional to the number of graph sheets we purchased, including the constant now. So let us go back to the board and see how we replace the proportional formula to include the constant. Okay. So the total cost of the graph sheets, y, is equal to k multiplied by x. And in this case, so total cost of the graph sheet is equal to the number of graph sheets purchased multiplied by the constant, which would be the price of each graph sheet. Right? Is that what's going to make this be proportional to this number here? But you understand that?
Yes.
Right? So the total cost of the graph sheet is equal to the price of each graph sheet multiplied by the number of graph sheets that you purchase. Right? So if we were to say, if we need to find what the total cost of the graph sheet is, we would need to know what the price of one graph sheet is. Right? So we are going to learn, I'm going to give you an example soon for you to find out what the constant is. The constant is the number that does not change. In our situation here, it is the price of the graph sheet. Okay? Okay. I'm going to give you an example here. Michelle travels, the distance Michelle travels is directly proportional to the time she spends on the road. The distance Michelle travels is directly proportional to the time she spends on the road. Can somebody explain the understanding of that? What do you understand by that? The distance she travels, so she travels 5 miles, it's directly proportional to the time she spends on the road. So,
I don't know if it spends on the road as the distance travel. If you spend, like, for example, 1 minute on the road, then 1 minute is equal to, let's just, for example, 2 miles. So every minute she spends, it goes up by 2 miles.
So in other words, the longer she spends on the road,
it's equal to what?
The more miles.
Miles that she
yes. Okay. All right, very good. Is that how you understand it? Okay. All right, very good. So the more, the farther she's coming from, the more time she will spend on the road. So distance would be directly proportional to the time, right? So as she goes further, that means she spends more time she will spend more time on the road. All right? How many of you live at this school? Okay. So nobody lives here, right? So you all travel to get here, right? So one person may travel 1 hour to get here. The other person may travel 2 hours to get here, right? So if you travel 1 hour to get here, it means that you would have covered more or less distance than the person who spent 2 hours. Right. So if you spend 1 hour traveling straight, non-stop, at the same speed from your home to get to work to school, it means, therefore, that you would have covered less distance than the person who did the same thing, and it took them 2 hours to get here. Right? So in our case here, Michelle travels, the distance she travels is directly proportional to the time she spends on the road. If she spends 5 hours on the road, she travels 30 miles. Right? So if she spends 5 hours on the road, she travels 30 miles. You think you'll be able to determine how far she will go if she spends 3 hours? We can find that out. Okay? What do you think we need to know?
The time it takes for 1 minute.
Okay, so let us put this into our equation on the board. Let us put this into our equation and see if we can find it. So, the distance Michelle travels, y is proportional to the time she spends on the road. Right? So if she spends 5 hours on the road, she spends 5 hours on the road, and she traveled 30 miles. Right? We need to find out what is the constant, what does not change. So we are going to say 30 miles is equal to k times 5, right?
Yes.
Okay? All right, so how do we know what k is equal to? We've done that before. You already know how to transpose.
Yes.
So can you help me out here? What do we need to do?
We need to make the k be on the side by itself. So that means we need to divide that side by 5.
Okay, so since this is multiply, when we change it.
Right, so we divide it. Right.
So 30 divided by 5
Is equal to k.
is equal to k. Right? So 30 divided by 5 is equal to?
6.
Okay, so 6
Is equal
is equal to
k.
k. All right? So k in this case, the constant would represent what? The k here, the constant, would represent how many miles she's going per hour.
Right. Oh, yes.
Right? So now, since we know how many miles she's going per hour, the constant, you should be able to tell me if she travels for 3 hours, how many miles she would go. So we need to,
I see now. I see.
so we need to find out how far she will go. So in this case, we need to find out what the y is, right? So y is equal to the constant k, which is equal to 6 multiplied by, she wants to travel for 3 hours.
Yes.
So 6 multiplied by 3.
Correct.
Okay? So therefore, the distance she will travel if she spends 3 hours on the road is equal to 18 miles. Okay. Right. Okay, so do you see any direct proportion here? As the number of hours she spends on the road, when she spends 5 hours on the road, she travels 30 miles. Right? But when she traveled for 3 hours, she only covered 18 miles, right? So when something is directly proportional to another, it increases together or it decreases. Right? So as the number of hours went up, the number of miles also went up. As the number of miles went down, the hours on the road also went down. Okay? So we say that the distance Michelle travels is directly proportional to the time she spends on the road. Okay? Everybody understand?
Yes.
Okay. I have another one for you. And you know why we're using these examples? Because a lot of people are afraid of math because they don't know that mathematics can be used in your daily life. Right? Mathematics is very useful in your daily life. We use it for a number of things. Right? I'm going to give you another example, which I'm sure you can relate to also. Sometimes when it starts raining heavily in St. Lucia, the school gets a call from the Ministry of Education, depending on how long it's raining, how heavy it's raining, and they will say, dismiss school at 12 o'clock, or all schools have to be closed by 1 o'clock, and so on, right? Because based on probably historic information collected by the National Emergency Management Authority or the Met Office or so, they can tell you how soon it will flood depending on the rainfall per hour or so, right? Depending on how much rain is falling. And you know we have some very low bridges, so if they predict that it's gonna rain so much over a certain time, they'll say get home before the streets start flooding. All right? So I have an example here for you. If it's raining 2 inches per hour, so there's 2 inches of raindrop per hour, how many inches of rainfall should we expect after 5 hours? Did you know that we could be using mathematics for all these things? Right? So the more, if it's raining 2 inches per hour, the longer it rains, the more rainfall we will have. Right? So you see any direct proportionality in that? So if it rains less, then we should have less rainfall. As it rains more, then we would have more rainfall. All right? Okay, so I have another example here for you. How many inches? So it's raining 2 inches per hour. How many inches of rainfall should we expect after 5 hours? Can I get a volunteer? Can I get a volunteer? Okay, somebody from Jamaica.
Yeah, can you repeat the question? Can you please repeat the question?
If it is raining there are 2 inches of rainfall per hour. How many inches of rainfall should we expect after 5 hours?
10.
You see, we know that math could be so useful in our everyday lives.
Okay, so after 5 hours, we should have 10 inches.
We should have 10 inches of rainfall. Okay. Can you explain to the rest of the class how you got that done?
Okay. All right, so your model says, the model says x is equal to ky, right? Right?
Oh, okay, y equals to kx.
Y,
but that's
right, all right. That makes more sense. Y is equal to kx. And
right.
you have 2 inches. You have 2 inches in 1 hour. Yes, so 2 is equal to k times 1.
Very good.
And then you divide both sides by k. So k is equal to 2. I mean, k is equal to 2. You don't need to divide anything. So if
right.
on 5 hours, you're just going to multiply 2, which is your k, times 5, which is your new x, to get 10.
Okay, does everybody agree with that answer? Did everybody get the same answer?
Yes, yes.
Okay, very good, very good. All right, so if it were to rain for 3 hours, would we have less than 10 inches of rain or more than 10 inches of rain?
Yes.
Less. Okay, so we can fairly say that the inches of rainfall then is directly proportional to the length of time it rains, the number of hours it rains. Do you understand that?
Yes.
Yes.
Okay, and you agree to that?
Yes, we agree.
Okay, can you think of any other scenario in your everyday life that we could use direct proportion or direct variation to solve? Can you think of any other useful way that we could use direct variation?
In cooking.
Just your everyday life, just being around. What else can you think of?
In cooking, if you have a recipe. Right, so in general, if you have, for every 1 cup of flour, you would have a half cup of sugar. Then you know if you need to make a bigger cake and you're using 2 cups of flour, then you need to multiply your amount of sugar by your constant, your proportionality constant.
Okay, very good. So even if you are in a restaurant or bakery, you find that mathematics is very useful, and especially in this case, the direct proportionality, right? Direct variation. Very good. Now I would like you, since you already know how to plot a graph, because as I said before, usually we look at trends and we plot it on a graph so you can actually see the visual. So you can see as something increases, the other one also increases. So for example, using the example of the travel, Michelle's travel, would you be able to plot that on a graph? Michelle's travels?
Yes, sir. Yes.
Okay. Could you do that in 2 minutes? And share with the rest of the class? Michelle travels she spends 5 hours on the road and she travels 30 miles. How far will she go when she spends 3 hours on the road? So I want you to plot when she spends 5 hours on the road and when she spends 3 hours on the road. Somebody done? Is everybody done? Okay. Okay, somebody in St. Lucia is ready. Diane? Are you Diane? Are you done, Diane? Geffa?
Can you all hear her, Diane? Can you hear her? Okay, so
Diane, can you hear me?
Carlene, you have to start wrapping up. So you have talked
Okay.
5 minutes.
I'm almost done.
Okay.
Okay. All right, somebody in St. Lucia is complete. So I'll just share it with the rest of you. Okay. So we have a graph here showing at 3 hours, Michelle would spend 18, at 3 hours, Michelle would cover 18 miles, and at 5 hours, she would cover 20 miles on the road. Okay? If you 30 miles. If your graph looks like this, you are correct. Okay? All right. Now, can somebody remind me of what direct variation or direct proportionality means? Diane?
My internet is dropping and coming off.
Okay, can you remind us of what direct variation or direct proportion, as it is also known, can you remind us of what it is?
When two quantities increase or decrease at the same rate in the same direction.
Okay, all right, thank you very much. Very good. Okay, I also have homework for you. So this is your homework for next class. It is due at the next class. Write it down for me, please. When Usain Bolt runs for 10 seconds, he covers a distance of 100 meters. When Usain Bolt runs for 10 seconds, he covers a distance of 100 meters. What distance will he cover if he runs for 15 seconds? You are to solve that using the equation, and you are also to plot that on your graph. Okay, plot that on the graph. In our next class, we will look at another form of variation, inverse variation. Okay, so if you have time, you could start looking at it or start reading about it. Inverse variation, we will be looking at that in our next class. All right, students, have a good afternoon. Thank you.
Thank you.
We need to use your computer to operate the PowerPoint.
So just sit here. So you color your own.
Yeah.
Where is it? Put everybody's in your email. So to use it. All right. You send it to me? All right.
Hello?
Yeah. They need to
Screen down.
Good afternoon, class.
Good afternoon.
Okay, today we're going to begin our lesson with us. Start activity. If you already sent an email, so you can just Zoom. Yeah. So take a step, right?
I got it.
Yeah, you can open your email phone, please.
I got it as well.
Yeah. There's an activity I want you guys to do. Put plus. Huh? That's it. Slideshow.
Yeah, there's it.
Slideshow.
Can they see it on their screen?
Yeah,
They can see.
They can? So
Alright.
we never share them.
Alright, good.
Yeah, so even though you are seeing the box, they are not seeing the box.
Alright, class, you have 1 minute to complete start activity. Put plus or minus in the empty box to achieve arrive at the given answer. First person to finish will receive a chocolate. 5 minutes.
Now I want my chocolate, you know.
Me too, a real one this time. Yesterday, the $1,000 was fake. So.
45 seconds. One minute.
Finish.
Finish. Okay, Jeffa, what is your response to the question activity?
6 plus 3 plus 6 is equal to 15.
Very good.
9 plus 9 minus 2 is equal to 16. 8 minus 1 plus 5 is equal to 12.
Very good, Jeffa. Anybody else have any other response?
You're supposed to ship my chocolate to St. Lucia.
Okay.
One made in Jamaica.
Okay, okay. I will do so, Jeffa. All right, class, question. Have anyone of you ever used a ladder to climb a tree? If yes, tell us how would you do it?
How you use a ladder?
Or if not, tell us how would you do it?
Going on each rung, one rung at a time.
Okay. Okay. Zana, can you tell us your response? Okay, we'll move on to Jeffa.
Hello?
Yes?
Can you repeat the question, please?
Have you ever used a ladder to climb a tree?
Mm-hmm.
You're not seeing this?
No, I haven't.
Okay, if not, tell us how
But
you use a ladder to climb a tree.
I've never used a ladder to climb a tree, but I'll just tell you how you can use a ladder. One step at a time. Just like Anya said. You put your right foot first, then your left foot.
Okay. And you go towards the tree, right?
Yes.
When you get to the tree, what do you do after?
Oh, I have to give the whole process. I have to get the ladder, put it across. I have to give all of that. I thought the ladder was against. Okay. Well, you get the ladder, you rest it at an angle towards the tree, right? I'm going right? Then you try climbing, like Anya said. You try to take one step at a time until you reach the top or wherever you're going on the tree.
Okay, very good. Diane, do you have a response to that?
Ladder to tree, climb the ladder.
Okay, very good. All right. Now the reason why, all right. What about the elevator? How you move towards the elevator? How do you get to an elevator and what you will do?
You take steps towards the elevator.
Yes.
Then you press the button. You wait for the door to open. Then you get into the elevator and you press the number in terms of the level that you want to go.
Okay.
And then the door closes and it goes.
All right, very good. And you can go up and down, right?
Right.
All right, very good. Okay, now let us go back to the process of climbing the tree. You were at one point, you say you would take one step at a time, right? So basically where you are, you will be at a certain point and then you would move towards the 3, and then when you get to the 3, you do what? Go up, right?
Yes.
All right, very good. Now, I'm going to follow you. I'm going to use, so for example, a flat surface. All right, we're going to count the steps. So you take X amount of steps towards the tree, and then when you get to the tree, you go up. Now, if I should represent this movement on a flat, for example, a graph paper, right? We could count the small boxes, how many steps you make towards 3, and then how many steps you would use to go up the tree. Yeah. Okay? So on your screen, you will see the movement of you in your backyard, and you will count the amount of steps using the boxes. So you do walk towards the tree direction, and then you go up when you get to the tree. All right. Now, the reason I want to use this is to highlight the movements of you moving towards the tree and also direction. All right? So you actually at a point and you find the location of the tree. Now, so for example, if you're in a classroom and there's an object in the ceiling and you are standing at the door, and I ask you to take some steps from the door to get to the object, right? You would count your steps from the door to the for example, okay, class, this is the board representing inside the classroom, and this is where the door is. And there's an object at the top of the ceiling, right? And you're asked to move from the door towards the object in the class. Now you have to make your walk, counting your steps, okay? And then after you reach near to the object, you are asked to, you reach near the object, you are not in line with the object directly, you are partway. So you do what? You would make a turn towards that object, right? You would make a turn towards that object until you are exactly in line. Now, I'm going to use some small tape to count your steps. So you have made 1, 2, 3, 4, 5, 6, 7 steps. And you are partially in line with the object, but you need to make another movement from the center of the classroom towards the side so that you can in line with the object, exactly in line or standing underneath the object. So you count your steps that you make towards the object when you make a turn. and there you are in line with objects. So, for example, this is the light in the ceiling where I'm standing. Now I'll be in line with the object. So basically, I'm at the exact location of the object in the ceiling. Now, this step that you make, the steps that you count, we could use something to represent those steps. Can anybody tell me what is the step, the thing that I'll use to count my steps? Diane? Jeffa, can you tell me what thing in math you could use to count our steps?
I don't understand the question.
You don't understand the question? All right.
Unit.
Unit?
I'm not sure I'm getting the question.
Okay. For example, just remember that when I was talking about the box where you use to count your steps to get to the object. What thing I could use to count the object? Just reflect on the previous list that you have done.
The tiles, your feet.
Yes, sure. But how do you represent that? Say, on the board.
Each tile would be 1 unit.
Very good. Each tile will be 1 unit. So each tile represents 1 unit. So therefore, if you start at 0, which is at the front, at the entrance of the door, and you have made several steps into the classroom to get towards the object, what you will say that represents?
I'm hearing parts of what you are saying. If you have, the internet is giving a lot of trouble.
Okay. All right, I'm going to ask Mona. Alyssa, what will you use to represent the steps and entrance? Yes, what does this thing represent?
Kind of looks like a number line.
Okay, very good. It looks like a number line. So you could use a number line to represent your movement from the door towards the object. But Alyssa, you mentioned something about number line. Now, when I get to the object, I'm not still in line. Okay, I'm like this. How would I move to be at the exact location?
That looks like you're going on another number line.
Very good. You would use another number line to get to the exact location of the object in the ceiling. Okay? Now, with this 2 number line combining together on a flat.
You have your horizontal and vertical axis.
Very good. Vertical and horizontal axis. Very good. Now both of these lines together on the flat, we would call it the Cartesian plane, which is consists of the x-axis running horizontally and the y-axis running vertically. Now, in order for me to get to the exact location of the object in the class, I have to do something. I have to move in a particular manner. First, moving from the door, which would be my 0 point, I make some steps. And after I make a couple steps, I have to stop and then go up towards the object, which would be on the second number line. Now, combining both of these movements together, we would call them the coordinate pairs or numbers, so to speak. All right? Now I've made, for example, 4 steps on my x-axis and 3 on my y. So it end up right there on my Cartesian plane. Everyone following?
Yes, we are.
Okay? Now,
Yeah.
all right, so both axes coming together, using both axes, we would find our exact location, which would be our coordinates. And coordinate gives a specific reference point of an place, for example, location, or just about anything. All right, we can use the Cartesian plane to find location or specific places. Now, with this Cartesian plane, it has 4 quadrants. And each quadrant is unique by itself. Now, the first one, which is, it goes anti-clockwise. So therefore, the first point moving from our right, go to our left, is our number 1, first Cartesian plane, which is plus, plus,
Positive and positive.
and our second one represents negative, plus,
Post.
the negative will be your x-axis and the positive would be your y-axis. The third one would be negative, negative, and the fourth one will be positive, negative. Now, as I mentioned before, our Cartesian plane operates a certain way. Both numbers travel as twins or travel together, and you have to go on one axis first to get to the other. You would travel on the x-axis first, then the y-axis. Reason why I would say you travel first on the x-axis and the y-axis second is to give you the specific location. If you travel the other way around, your answer will be wrong. You have to follow the x-axis first, just like in the alphabet. X comes before y. So we quote that too by saying go on the x-axis first, then the y. All right?
It's conventional.
So it's conventional. Everyone following?
Yes, we are.
Okay. So we say that coordinates and the Cartesian plane are the same, meaning when you were moving towards a tree and climbing up, and also going towards the elevator and going up and down, we say coordinates are the same. You can move like, the movement in real life can be like coordinates. All right, if you want to find the location of a specific road or place in a community or in a country, you will have to follow coordinates to get to the exact location. So we say the definition of Cartesian plane is that is a plane mean that is flat, made up of an x-axis, the horizontal line, and a y-axis, the vertical line. And coordinates give the position of a specific reference point. We say the x-axis, you start at 0 and you move from left to right. Y-axis is the vertical line, and you move from 0 going up, and you also can go down. All right, there's a very interesting thing that you should know. Where the two lines meet, it forms the origin. And that origin has a special letter that represents it. The letter that represents the origin is O. All right? And that will be your starting point whenever you're on the Cartesian plane. Zero. Okay? So you can, the origin is represented by a 0, and that's the starting point. You always start at 0 on the Cartesian plane. So as I said, coordinate always travel in pairs by 2s. So first you go over, and then you can go up or down. Okay? But you always start at 0. Now, as we said, the letter represents X and Y, and they're normally in a bracket, and it's separated by a comma. So let us make the connection. Over and up and down is the same thing as over, meaning going along the horizontal line, x-axis. Go up and down the vertical line, which is the y-axis. And I have a couple examples I want to give you guys to see if you are really on peak. So can anybody locate 5, 3? Quickly draw a number line, both number lines, and represent 5, 3.
Hello.
Huh? Okay, anyone?
Can I answer the first one?
Sure.
For 5, 3, you're in the first quadrant. You move in 5 to the right.
Very good.
And 3 upwards.
All right, very good. What about 0, 0?
In at the origin.
Very good. So you don't move any at all. You're at the origin.
No, origin.
Yes. Some real life situation that we use coordinate numbers are, for example, pilots use coordinate numbers to find the location of place or to get to particular countries, and it also helps them with their landing of the plane. Sales navigators use coordinate geometry, Cartesian plane with coordinate numbers to find the specific location of a country and so forth. All right, can anybody tell me where the treasure is on the map?
Yeah.
Tell me the card.
2, 3.
2, 3. Everybody?
Yeah.
Yes.
Okay. What about the first? The first boat on
3, 2.
3, 2. Okay. Diane, can you tell me the second boat, please?
5, coordinates 5, 3.
Okay. So which axis the 5 is on?
On the x-axis, 5, 3. On y.
All right.
So now you turn the y-axis.
Okay, very good. All right, for homework, you're gonna plot these points on the paper, and you're gonna tell me what shape the points, the coordinate points make, the numbers make. All right, that's it. Bye.
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 Come in. Are you ready to go?
Yes. Where? Email it to them. So just like reply to one of the messages that one that is sent out. Understand? That's like reply to other messages. This is me. Oh,
Guys, remember you cannot give me a password piece of your ID number and your name. That's very important. Please don't forget it. Even if you need to have right discipline or somewhere, you cannot afford to.
so I'm trying to see if I can okay.
Can you try to for me? Can you try to for me?
So I will tell you when you're going to reach next slide here.
customize Avalloys.
Don't. All right, hi everybody. Can you hear me?
Yes, I can.
Okay, so today we're going to be learning about consumer arithmetic. And you would have remembered we started consumer arithmetic. Last week we looked at simple interest. So now we're going to go into hire purchase. And this is the introductory lesson. What I really want us to get out of today's lesson is the idea behind hire purchase. I want us to see how hire purchase works. What is it really? What do we use it for? And also at the end to be able to make an informed decision about whether or not we would buy something on hire purchase. Fair enough? All right. So before we go into this topic, I have a friend, right? Her name is Keisha and she has a little problem. So I want to see if we can assist Keisha with her problem. Do you have it on your screen? Are you seeing the presentation on your screen?
I'm not seeing on the screen.
No, I have it on. Check your laptop.
Okay, we're sharing it with you. We're gonna share screen. Are you seeing it now?
Yes, we can see it now.
All right, great. Okay, so let's see what Keisha's problem is. Next slide. I'm gonna ask Davy in Mona to read in a loud, clear voice Keisha's story for us. You can see? Oh, you don't have it on your laptop? Okay, who has it on their laptop? Okay. So Davy is reading Keisha's story for us.
Keisha is a young woman who just graduated from Teachers College. She got her first job as a grade 2 teacher at Gardenia Primary School. Her students adore her, and she loves her new job.
Next slide.
As a new teacher, she makes a modest salary which can cover her daily expenses, but doesn't leave her with a lot of extra cash. Keisha is concerned because her stove stopped working last week and she has no means of preparing her meals.
Next slide. Next slide.
She needs to buy a new stove. She has some savings in the bank, but not enough to buy a new one all at once. Suggest a method that Keisha can use to get her new stove.
All right, hold on. Okay, wonderful. So we said that Keisha has a problem, all right? So her stove stopped working. She can't afford to go out to the appliance store and buy a new one. She doesn't have that much money in the bank, but she needs a stove, right? You cannot keep eating at restaurants. It's not healthy and it's too expensive. So Keisha and I were looking in the newspaper and we saw a Quartz ad. All right, I'm gonna give you 10 seconds to look at the Quartz ad and then I'm gonna ask you some questions about it. Thank you very much, Davey. All right, so we're looking at the ad. This is the ad that we saw. What information pops out at you concerning the cost of the stove?
It's about 60,000 Jamaican dollars.
So 60,000 Jamaican dollars cash, right? And what does that mean to pay cash?
Well, if you pay credit card, debit card, check, you'll get it for 59 $2,999.
Okay, all right. Anybody else has another response? But that was very good. All right, so that's basically, so if you pay for it all at once, this is what it costs, 60,000 Jamaican dollars, 59,999. Okay, but what other information do we have there?
You can pay $1,069 a weekly.
Right, so this ad is saying, okay, you can pay this amount of money cash, but if you don't have that all at once, you can pay $1,069 weekly. Sounds like a good deal? Over what period of time? Coming to that, all right? So Keisha is a little bit skeptical, right? Because she's saying she knows that businesses are in it to make money, right? So she knows that although they're saying you can pay this low cost, there's something in it for them. They're not just gonna give you this benefit for nothing, right? So what is hire purchase? Does anybody know? Does anybody have any idea before we move to the next slide? What is hire purchase? Maybe your parents bought something on hire purchase, or maybe you heard somebody talking about it.
Buy now, pay later.
Okay, so you buy now, you pay later. Very nice. Anybody has any other spin on it? Ingrid?
You don't pay the full amount initially, you pay small amounts.
Okay, so Ingrid is adding to that. So she says you don't pay the full amount initially, you pay small amounts over a period of time. And that's very good. Next slide. Okay, so hire purchase, and I'll read for you to save time, is a system for purchasing items such as cars or furniture in which the buyer pays for an item in regular installments while enjoying the use of it. In regular installments. What is an installment? Does anybody know?
A certain amount you have to pay every month or every week.
Yeah,
who is that, Tasha? Or was it Diane? I heard Geffa.
Okay, Geffa is speaking. She almost said the same thing I would have.
Oh, the same thing. Okay, so Geffa said you pay a certain amount every month or every week, right? Usually it's the same amount. So you pay equal payments periodically. So every month or every week until you've paid the full cost. And that's great. Okay, so now we have a little video on hire purchase. I want you to watch the video, and while you're watching it, I want you to think of 2 advantages, at least 2, you can write as many as you see, 2 advantages of hire purchase. If you can't see or hear, wave.
I can't see it.
Can you pause? Please?
Not in the video.
It won't work here. Okay.
She can't see it.
She can't see the video.
Looks like she's seen the share screen.
Can you see the share screen?
You can.
It's not coming up here.
I can see the screen, but not
only the PowerPoint that's shared.
The video is not being shared.
Only the PowerPoint is.
If you copy that link and paste it into your browser, though, you'll see it.
We can't.
I'm sorry, guys. If you copy the link, you can't copy the link.
We cannot copy it because the screen is shared. We can't click on it.
Yeah, I realize.
Can you copy it where you are and share it on your screen?
Just play the video and it will play it.
They will see it. Seeing it now?
Yes, we can now.
Okay, great.
Meet Jenny. Her car can't keep up with her lifestyle. She'd love a better car, but hasn't saved up enough yet. However, a higher purchase loan allows Jenny to borrow a set amount of money over a agreed period with a fixed interest rate. Jenny chooses to buy a car for £10,000 over 48 months. The amount borrowed and interest added is put into one amount, which is divided over the 48 months equally. Jenny pays the same amount each month. If she wishes, Jenny can pay her loan off early. After the 48th month, Jenny owns the car with no further payments. This makes Jenny very happy.
Okay, that's the video. You need to see it another time, or can you write your advantages now? Can you write advantages now, or you need to see it one more time? Jamaica? Okay, guys, you have 30 seconds, write 2 advantages of hire purchase that you can think of.
Right.
Okay, anybody ready to share? Anybody ready to share?
On hire purchase, you do not have to take as much cash out of your account, so therefore you have more disposable income per se, or saved income. That's one advantage. The other one is she can use the item even before she has paid the full price for the item.
Excellent. Does anybody else have anything? Does anybody have anything else? Okay, but those are very good. So next slide, please. No, before. Okay. So I have 3 advantages here, and Geffer gave 2 of them. She said the purchaser can make small, affordable payments instead of one large payment. So you don't have to go and take out all of your $60,000 out of the bank at one time, or maybe you don't even have $60,000 in the bank. You can make small payments. The next one is that you can take the item home as soon as the first payment is made, right? So it's not a layaway plan where you start paying now in June and you pay a little bit now, a little bit in July, a little bit, and then finally by Christmas you have your gift, but it stays in the store until Christmas. You take it home immediately. And the third one I have, the third one is that the purchaser will eventually own the item. So you're paying monthly, but it's not like you're renting it, right? So you'll be familiar with rent. Maybe you live in a house, or you know somebody who lives in a house that is rented. You pay money every month, but if you live in a house for 30 years, you still don't own it because that's not the agreement. So eventually you're making payments. You take it home now, and eventually you'll own the item. So that is the hire purchase model. All right, so now I have a diagram. What is this diagram saying to you? There are 2 cars. So you have a complete car on the left and on the right, and on the left, you see kind of like a silhouette or like a covered up car. What are you getting from that? Are you getting anything from this little diagram?
Your deposit plus your monthly payment.
Yes.
So to get the car, you need deposits and monthly payments.
You need deposit and monthly payments. But look at the size of the deposit in comparison to the size of the monthly payments, which is smaller.
The deposits are smaller.
The deposit.
The monthly payments together will be bigger than the deposit.
Right. So initially you pay a fraction of the cost, right?
Yeah.
And then, so that would be a smaller portion. And then the lump sum, you would pay month by month or week by week. This model says monthly, but you really could be paying weekly. All right. So based on that, Geffer said deposit plus monthly payments this is probably the simplest way to calculate hire purchase. So oftentimes we'll go into a store and they'll just tell you, you pay this amount of money per month for this amount of months or this amount of years, and that's all you have to do. You know what you're paying for your deposit, and you know your installments, so you just combine them. There are two hire purchase models. The first one is your traditional model. This one requires a deposit, but nowadays a lot of places are offering the modern hire purchase model where you don't have to pay a deposit. So in Jamaica, we have a furniture store called Quartz. That's one of our biggest ones. And they say pay $1 down or no money down, and you can have your living room set for the low monthly payment of $10 a week, right? Not $10. Jamaican money is not that strong. But that's the idea. All right, so let's go back to Keisha's problem. She wants to buy this stove. It's $1,069 a week, but do you notice they don't put how long you have to pay that for? You notice? So they put on the ad $1,069 a week, but they don't tell you. When you go into the store now, then they tell you, well, you pay this $1,069 a week for 18 months. So if, remember we modeled hire purchase cost is equal to deposit plus installments. If she pays $1,069 a week for 18 months for a year and a half, how much money will she pay total? And I'm giving you a minute to work that out. I have a tip. Calculate 1 year as 52 weeks. I'll go back. Calculate 1 year as 52 weeks. Rather than 4 weeks make a month, because you'll get a different answer. I have 1 minute. 5 minutes. If you get it, raise your hand.
Can you repeat what you just said about the amount she deposited?
Okay, wonderful, good question. So do you notice it says nothing about a deposit on the flyer?
Yes.
So we can assume that we pay no deposit. So assume that this is the modern hire purchase model. We're paying no deposit, and she's paying $1,069 a week.
Okay.
You have it, Mona? Anybody in St. Lucia have it? Are you working it out? Okay, so yes, okay, good. So our hire purchase is deposit plus sum of monthly installments, which is 0 represents our deposit, right? And we pay $1,069 per week plus sum of installments. I'm sorry, that monthly should not be there. $1,069 per week times 52 weeks in a year times 18 months, how many years? It's on the screen. One and a half. Okay, and we get 83,362. So that would be our hire purchase cost. But recall, what was our cash price? $59,999, $60,000. So what are you seeing here? Are you seeing?
You pay more on higher purchase.
You pay more, a little bit more, significantly more. Significantly more, all right? So let us look at some disadvantages of higher purchase. You end up paying significantly more than the original value, and this is because they add interest to it. Now in our next lesson, we'll look at higher purchase and simple interest. For today, we're just doing the concept. Number 2, if you miss a payment, you will lose the item plus the money you've already paid. So can you imagine? You go down to court and you take out a big flat screen TV, right? And then something happens and you can't pay for a couple of months. They come and they take it back, right? And you lose all the money that you have paid so far. And thirdly, you may be in debt for a long time. So that's something to consider. Do you want to make this payment every month coming out of your salary for the next 2 years or the next 3 years? So that's something we consider when we think about hire purchase. And finally, number 4, if the item becomes damaged, you'll have to continue making payments for it. So let's say Keisha buys this stove and she decides to move, and while she's moving, the movers drop the stove and destroy it. She'll still have to keep paying for the stove even though she's no longer using it. So there are some disadvantages, some things we have to consider before we decide whether or not to do hire purchase. All right? Mm-hmm. So now that we are armed with this knowledge, we're going to do, not this one, next one, please. Next one. This one. Go back. This one. All right, so let's see if we have time to do this question that you see on your screen. A Sony PlayStation 4, and that's the latest video game, apparently, cost $62,000 cash. Plugged In Electronics Store offers 2 hire purchase options. You can either make monthly payments of $4,650 for 1.5 years, or weekly payments of $1,200 for 20 months. So the question says, which option would you choose? Give a reason for your answer. Okay. Okay, guys, my time is up, but if you work it through, you'll notice that your monthly payments would come out to about, your hire purchase cost would be $83,700. Your weekly payments would be $90-some thousand. And so you would determine, you can choose to go with the lower cost option, or maybe it's more convenient for you to pay this weekly. So it says, give a reason for your answer, right? All right, so thank you guys for participating.
You're welcome.
Yes. So pretty.
Okay, I want you all to yes. Good afternoon, guys. How are you?
Good afternoon. We're good.
Good afternoon.
Did you check your email to see if you received a handout? Because I'm not going to be using PowerPoint, so you need to find your handout. On linear inequalities.
Are you a Lisa?
Pardon me?
Are you a Lisa?
No, it's from Ingrid. And it's titled Linear Inequalities. It should be the last one I think that you got.
You didn't get any email?
I got it. It's in your junk mail.
Anybody else got it? Tasha didn't get it.
I'll send it for you, Tasha.
Okay, thank you.
Everybody else got it?
Yes, I got it.
Okay. Okay, good afternoon, class. How are you? Everybody's fine?
Fine. You're fine.
After lunch, you're all sleepy. All right, today we're going to be looking at inequalities.
We're continuing from our last class, and you're expected to already know what an inequality is. So can someone quickly tell me what an inequality is? We did that last class. We don't know? Okay, I'm not going to tell you. But we looked at inequalities last class, so we should know what the inequality symbols are. We should also know how to put our solutions on the number line. Our introductory activity, which is what we have on the handout that I gave you. What is the handout? Will maybe help to remind you of what an inequality is, as well as the symbols. If you're not certain, no problem, we'll help to remind you. You can work in pairs if, I guess, as much as possible. And what I want you to do is to look at your sheet, okay, and see if you can come up with, well, if you can tell me really what the first item on the sheet is saying, and the second, the third, the fourth, and then we're going to see if we can write those as inequalities based on what we did last class. Okay, so let's look at the very first one. Oh, I'm sorry, yours is right here. All right, the first one. It says persons younger than 14 must be accompanied by an adult. All right, would you think of that as an equality? Did they say something must be equal? Pardon? Did they say something must be equal? No. But the word used there to define what the relationship is what? Younger. Younger. So it's telling you immediately that we're not talking about something that's equal, but about something that is less. Less. All right? So or greater. It says younger than 14. So we can first define a variable to represent persons younger than 14. What letter do you want to use? X? Okay, so X defines the age of the person, and the person must be less than. So we could write what inequality? What inequality could we write? For the first one. Jeffer?
One second, I'm having difficulty opening your file.
Oh, okay, I'm sorry.
X is less than 14.
Thank you, Dan. That was Dan? Yes, so Dan wrote X is less than 14. Okay, so I want you now to look at the other three diagrams and come up with an inequality to represent each. I'm going to give you 2 minutes to do that. And then after that, we're going to see if we can put that on the number line. Anybody through, although the 2 minutes are not up? No, we're just going to work the inequalities first, and then we.
The first.
Yes, Jeffer?
The second one is X is less than but equal to 15.
Okay, less than. Second one. She says X is less than or equal to 50. What is the third one? Pardon me?
X less than 4 degrees.
X is less than 4 degrees. Okay, I could say just 4 degrees for now. The other one? You could either give me the meter height. Anybody else wants to offer for the number 4? The fourth one. Okay, Davy says x is less than or equal to 2.3. Okay, very good.
No.
Are they agreed?
Yes.
Yes. All right, so here we have, well, 3 of the equality symbols. Can anybody tell me which one is missing? We have x less than 14, x less than or equal to 50, yes?
Greater than or equal to.
Okay, so the fourth one we have is greater than or equal to. Very good. Now we want to be able to put these on the number line as we did for last class.
You're also missing greater than on the board right now.
Right, as well as greater than. Thank you very much, Jeffa. So we also have greater than or equal to and greater than. All right, everybody's clear? So from last class, you should be familiar with all of these symbols. Okay, now let's see how we can graph this on the number line. We're not going to do all of them. Okay, we're just going to do 2, the first 2. Who wants to come and who wants to show me how to do the first one? X less than 14. Yes, David? Do you think so? Let's see. Come, David. David has volunteered to graph the first one on the number line. You can put it on the other side of it.
Good afternoon, everyone. Who's going to guide me through this? Number line. Okay. There. 0. That's positive in that way. Okay.
Going to 14, David.
1, 2, 3, 4. It's not great. Wrong side. 14. 14 is right there on the number line. So we go up to 14. Up to 14, but it is not included. So,
are you going in the right direction?
Less than 14. Less than 14. So
yes, I told you.
I didn't know. Come on, so anything from up to this point. So it's from 13 down.
The arrow goes to the left.
The arrow is going all the way down there.
To the left. Show the arrow.
The arrow goes, continues ad infinitum there, but you don't enter 14.
All right, thank you very much, David. Everybody can see what David did?
Yes, ma'am.
All right, what we prefer, if for example you do it this, I prefer when you put it above the line actually, rather than directly on it. So if you have the circle above the 14,
Or under it,
and you show the arrow going to the left to show that it is less than. All right, so everything to the left of 14 would be possible values of my first inequality would be less than 14. So it's the possible values of x. Everybody agrees? Yes. What about the other?
Agree.
Thank you very much.
Agree.
Good. What about the other one? X less than or equal.
Can I try?
Yes, Jeffrey, go ahead.
Okay, can you draw number line for me, please?
Number 9.
Mark 0 from the beginning and 50 somewhere on it. You can mark 0, yeah.
We want 0 here. Okay.
Yes. Okay, I want you to draw a circle above 50 and shade it. And an arrow to the left.
Okay. Thank you, Jeffrey. Everybody sees
And you forgot You forgot to tell Davy. You have to always write your inequality at the top. The inequation, sorry.
Yes.
At the top when you're drawing.
Right. Thank you very much, Jeff.
Thank you, Jeffo.
All right, so we have this here
Welcome.
drafted. Yes? And we notice that when it's not equal to the value, we will use a
circle, not shaded.
Or an open circle. And when it's equal to the value, we use a
Shaded one.
shaded one. Okay, we're getting into a lesson for today. We're going to look at solving linear inequalities. Now that you have revised what the symbols are, and we know what they are, we know how to put them on the number line. We're now going to look at how to solve linear inequalities. And we're going to start with the simplest forms, one-step inequalities. And we're going to look at the addition property, subtraction property, and the multiplication and division property, and how these apply to solution of inequalities. Now, I don't know how many of you have your algebra tiles. If you don't, it's still okay, but for those of us who may be more tactile, you want to use our algebra tiles to model the inequalities that we're going to look at. And we can start with a simple scenario. Let's start with something as simple as we're going to now look at how what the addition property and the subtraction property as it relates to inequalities are. So let's start with inequality 2 is less than 5. Can you model that with your algebra tiles and the less than cards that I gave you? Let me draw what you have on the board. For those of you who need the tiles, some of you might be able to do it without the tiles. No problem. So we have 2 is less than 5, right? Everybody agrees with that inequality. It's correct, right? What happens if we should add 1 to both sides of the inequality? What should happen? What we're going to have next? So we're going to add 1 algebra tile. So if you put your tiles, you're going to get, how many are we going to have on the left? 3. And how many will we have on the right? 6. So we're going to get 3 is less than? 3 is less than? 6. 6. Very good. Is the inequality still true?
Yeah.
Okay. So
It is, yes.
it is. Okay, good. So can we draw any conclusions from that about what happens when we add something to both sides of an inequality?
Remains true.
It remains true. All right. So we could write our statement. When we add a number to both sides of an inequality, it remains true. Isn't that right?
Yeah.
All right. This is called the addition property. All right. Do you think it would remain true if we did a subtraction? If we were to take away 1 from both sides of the first inequality on the board, would it remain the same?
Yes.
Because you would guess what? You have to take away 1 from both sides.
1 less on both sides.
1 less on both sides. So you're going to get 1 is, which is still true. So if we subtract a number from both sides of an inequality, it still remains true. And this is called the subtraction property. All right? Everybody clear on that? Is everybody clear on that?
Yes.
All right, very good. We're now going to use it to solve an inequality. So let's look at this problem. We're going to start with a problem. Jane has $50. She must buy a notebook Okay, so it says Jane has $50. She must buy a notebook for $30 and pencils for $5 each. What is the maximum number of pencils that she can buy? Everybody heard that? Can you see it?
Yes, we can.
Could you write an inequality for that? If we call it pencils P, the number of pencils P, what inequality could we write to represent that?
50 is greater than or equal to.
Okay. Is greater than
or equal to 30 plus 5p.
Okay, thank you, Jeffer. Everybody agrees? Sure. This is my next problem. All right. Okay, I'm going to change the question slightly. I asked the wrong question. This is for the second part of my lesson, all right? Okay, it's not really what is the maximum number of pencils she can buy, but what is the amount she can spend on pencils? What is the maximum amount she can spend on pencils? That's for the other part. All right, that's what should be there.
$20.
Well, the answer is $20, but can you write the inequality for that? The amount she can spend on pencils is P.
5p is less or equal to $20.
Pardon me?
5p is less or equal to $20.
Okay, that's the solution. All right, we're looking only at the maximum amount she can spend on pencils. And I'm saying let the amount spent on pencils be P. What inequality should we write there for? Let me take this off because that was wrong. It's similar to what we had before, except now we don't need to consider the 5 because I just want to know how much she can spend on pencils. All right? So we could write the same thing, 50. Isn't that right? Not the number of pencils, you know. The total amount she has left to spend on pencils. It's not the total number of pencils, but the amount that she can spend on pencils. All right, everybody's getting the question? Everybody's getting the question? Okay, we want the amount she can spend on pencils. So she has at most $50. Okay, so $30 is spent on the books already. So she only has P left to spend on pencils. All right. Now in the previous example, we noticed that if you take away something from one side of the inequality, it remains the same. And we also noticed if you do what? Which remains true, yes. And if you add something to both sides, it also remains
the same. True.
Okay, so what could we do with this to solve this inequality? If we want to find the value of P.
Subtract 30 from both sides.
We could subtract 30 from both sides. So we'd write what?
50 minus 30 is greater than or equal to 30 plus P minus 30.
All right. So now we have what?
So we have 20 greater than equal to P.
So the amount she can spend on pencils is what?
20.
She can spend $20?
Yes.
Only $20?
Yes.
Does she have to spend $20?
20 or less.
What can she spend on pencils?
$20 or less.
$20
or less.
Less. All right. So this is a solution to our
question.
Inequality.
But you asked the maximum, so maximum would be the full 20.
$20, right? Very good. Very good. Thank you, Jeff. All right. So having done this now, we could put this on the number line. All right. How could we put this on the number line?
You draw a number line, you draw a line, and you put.
So I draw my number line?
Yeah, you draw a line, you have 0 somewhere to the left and 20 somewhere to the right. You're going to put a shaded circle above 20 and put an arrow going left from it.
Okay. So this will give me my solution. And we have? All right, any questions?
No.
Which property did we use to solve this inequality?
Subtraction property.
We use the subtraction property. All right? Okay, I'm just going to ask you now to just get together, well, on your own. Okay? You could create your own inequalities and exchange with a friend or the person sitting next to you to solve. All right? Next class, we'll be looking at the multiplication and division properties for inequalities. All right?
Okay.
Your homework exercises from your textbook. Page 47, exercise 5A, numbers 1 to 4.
Okay.
All right, thank you very much.
I want to quickly address something. Alright, now, are these two different symbols? Are these two different symbols, everybody?
Yes, ma'am.
Nice.
Yeah? No, then
One is greater than.
it's one symbol is how you read it. Yeah. So if I have 2 and I do this, it's one symbol. 2 is less than 5, but it's also true. 5 is what? Greater than 2. So it's one symbol. We don't teach 2 symbols because that's why the students are confused. So if I have this, let's say I have 5 and 10 here, and I need to figure out where, or even 11 and 2, and I need to figure out, I probably just ask them to put in a symbol. How do I know which one is bigger? In this case, 10. I put 2 dots here for the bigger one and 1 dot at the small one, and I close it. Now, I can read it where the 1 dot is always less, where it open is always greater. 5 is less than 10, or 10 is greater than 5. It's one symbol. If we look at this, which one is bigger? 11, 2 dots, 1 dot. Bigger one is 2. Close it. 11 is greater than what? 2. And 2 is less than 11. So it is really one symbol. And that's how we teach it. Okay?
Yes, ma'am.
The idea is that our students try to figure out if we go which one hand left. And it will take them a very long time and really confuse them.
My grade 2 teacher told me that the shark opens its mouth to the bigger food.
Exactly. So you can use that method. You can use 2 dots for more, 1 for whatever method you use. But the main idea that I want to get to you, I don't want to interpret this. I don't want to see these as 2 symbols. It is one symbol, but it's how you write it and how you read it that makes a difference. Are we all following that? And once you start telling 2 symbols, this is just going to clear chaos. And it's one symbol because it can be read from forward to backward and from back to forward. And the statement still stands. Are we following that? So this is still, this doesn't matter how we read it, it's still, so it couldn't have been 2, it must be 1. Am I making sense to you all?
Yes, but question is,
Yes, you are.
This time is a different direction, different. That probably why first might teach it as 2 signs.
I see the point you're making, saying it's 2 ways of what greater than less than.
Yes.
But greater than less than is determined on the position of the symbol. So that is it. That's all you need to tell them. Yes, you have greater than and less than, but this is determined by how we position the sign. So once you start to tell them, because as students get up in my class, I'm trying to figure out which one is right hand, which one. Yes. So we're trying to cut because it's really the part that I can't. And I realized that when Ingrid was teaching, and I don't mean anything about Ingrid, please don't take any offense. When she read 2, she read it always 2 is less than 5 because in her mind it's the less than symbol. You recognize that she was always. But if you look at the question,
you read from left to right.
I read from left to right.
Yes, that's what you said.
yes, but you can read backwards also. 5 is greater than 2, and the statement is still correct.
Yeah, that's true. I just read from left to right.
Yes. So when you represent it, you have this. And then you have your 1, 2, 3, 4. I just don't want to walk away with this and teaching this anymore. And you have a symbol. But as I look at it, I can say that 5 is greater than 2. And as I look at it, I can say 2 is less than. As I look at it, even when I represent it visually, as I look at it, I can see it. All right? Any question? Well, you don't have to agree with me. This is method. But yeah, it makes sense.
It makes sense. Because they always have a problem saying turn the elbow this way. I get them doing that.
Yeah, man, it's really.
The elbow?
No,
oh yeah, that's the one I. That's the one I.
So I know that's one method to remember how you read it. But the main thing I want you to walk away with, the main thing is that it's really one symbol, and it's one symbol because it can be read both ways. Both ways of reading it, and the statement is still correct. So even when you're looking at when you prove it and when you twist it, you're dividing it by a negative coefficient and whatever. Why? Because when you are reading it now, the statement is no more true. That is the reason why you reverse the symbol. So once you look at it, the statement is one symbol because it doesn't matter how you read the statement is true. So that's the idea that we want to push. All right? Go. Come here.
Try something. I need to know.
All right, we have one more lesson. So while he's getting ready, you can start think about this in the meantime. Now, we're about to discuss the class, the lessons. But what I also want you to think about is, do you want me to share the scores with you and we can look at the difference? But I have a rubric. I do have my rubric. You have my rubric. So, what we're going to do is we're going to look at listen up.
We're listening.
We're listening.
Is it that you want me to say your score out loud so we can talk about why some person gets such high scores? Well, nobody really gets any low scores, but try to understand the difference and what are some of the things I was looking for. So you can decide as a group, because I don't want anybody to say Miss McCarthy taught them grade out loud. So
Yes,
it's for you.
yes, miss. We would like you to share them. Well, I would like it.
So it is something that you have to reach some form of consensus on for me to decide to do that. If not, I just have to WhatsApp you personally your grade, okay? So this is something that you all need to decide on. So if you want that rich discussion and you want to drop the pride, we can have that. If not, then I just WhatsApp you individually, whatever you get. Some persons are aware already, the ones that can teach here. They already kind of have an idea what they get and why. All right? One more person.
Right triangle.
Start here.
Green chair.
Did they blank? Somewhere did they blank the screen?
The share screen.
No, man, for the PowerPoint here.
Yes, it's on blank screen.
It's on blank screen?
It's blank
So,
screen.
okay, so okay.
Well, that's what it says.
Need someone.
Yes, you want.
Thank you very much. It doesn't work from here, baby.
Huh?
It don't work from here.
It's okay. All right. We can leave it for now. Can I go now?
If the person's not straight, if we decide to go ahead. Go ahead.
All right. Good afternoon, everyone. Jeff, are you hearing me? Zana?
Yes, we can.
Okay. Now, I sent you all some worksheets earlier. We're going to need those because this topic is highly interactive. So, do you have your worksheets?
Yes, we do.
Okay, and do you have your protractor, your ruler?
Yes, I do.
Your math kit, do you have your math kit ready?
Yes, it's there.
I'll take that as a yes and move along. Okay. Today we'll be discussing trig ratios. We have already seen in this topic Pythagoras theorem, but it is not enough just to know Pythagoras theorem to solve all the real world problems that come at us when we're dealing with angles and triangles. As Pythagoras' theorem, as we discussed last week, applies to the sides only of a triangle. It does not enable us to calculate the angles of a triangle without any knowledge, any further knowledge. So, at least I remember. Right. So we have here a problem. An engineer. Alexa, can you read the problem for me?
Okay. Engineers need to design handicap ramps to code. The angle of the incline must be less than 5 degrees. An engineer measured a ramp to be 12 feet long along the ground and 1 foot in height. Determine if the ramp will meet the code requirements.
Okay. So as you can see from the problem that we have here, we know how long the ramp is along the ground, and we know how high it is, or how high it should be. But will it meet the standards? Would it be too steep to push the persons up the ramp? How would we go about solving this problem? Any suggestions? All right. Okay. So this is where we need to know how to calculate the angle. Yes? But to do this, we need to know what is the relationship between the sides of the triangle that would be formed, because Pythagoras' theorem would only give us the length of the hypotenuse, which would be somewhere around a little bit more than 12. Square root of 12 squared plus 1 squared from Pythagoras. If you all remember, that would be square root of 145. So it just gives us the length, but not the incline or the slope. So to calculate the slope, we are going to need a little bit of help to go on this journey of discovery. So I'll ask one of our friends who we have met before to give us some insight.
Before we start learning about trigonometric ratios, we must learn a few things about this right triangle. Now, the reason I know I'm inside a right triangle is because of this little box. This little box serves as an indicator that this angle measures 90 degrees. Now, let's learn something about the sides. A right triangle has one side that is longer than the other two. Now, if you can't tell which side is longest, just by looking at your right triangle, try doing this. locate your 90-degree angle and look opposite. This side is the longest side of my right triangle. This side has a special name. It's called the hypotenuse. 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 Now, the name of the other two sides depends on which angle we're talking about. Say, for example, we're talking about this green angle. If we're talking about this green angle, then this side is next to it. Another word for next to is adjacent. This side is adjacent to the green angle. This side is still your hypotenuse, which makes the bottom side opposite. The bottom side is opposite to the green angle. So there you have it. Hypotenuse, adjacent, and opposite when we're talking about the green angle. Now let's talk about the yellow angle. This side is next to the yellow angle, which makes this side adjacent. This side is adjacent to the yellow angle. This side is still the hypotenuse, so that makes this side opposite. This side is opposite to the yellow angle.
Okay, so I got that. Next one, please. Okay, so from what we just heard, with the ratios that we are looking at are the ratios of the sides of the triangles to determine how we get to the angle of the triangle, because we do not have anything we haven't met anything previously to determine the angle of the triangle. And what we have been given in this problem is just the sides. So we're going to use our mathematical concepts, knowledge, to determine a ratio or a way to solve this real world problem. So what we have here are our ratios, the three possible ratios from that you would have from the triangle. So the ratio number one that we have there, I guess you can all see that. Opposite over hypotenuse, adjacent over the hypotenuse, and the opposite over the adjacent. Do you need to be reminded of where those are in respect to the given angle? No, I don't think so. It's on your diagram there. No. All right. I had previously sent you a tangram like sheet for us to do the experiment to determine if there is any constant or any ratio, any connection between similar angles on the triangle with respect to the sides. However, it was a bit involved, and it would take up a little too much time to go through all of that in 20 minutes. So I sent you another worksheet, which, Jeffrey, you're there? You saw that new worksheet with it?
Yes, I did.
Right, so I'll just move down. Next one. Right, that worksheet. Now what we're going to be using this worksheet to do this afternoon is...
Yes, I have this.
You have that worksheet. Right, so what we're going to be using that worksheet to do is to determine these ratios that we have here. So anybody, Jeffrey, you have your worksheet, your handout. Anybody has it cut out?
I didn't print it though.
Not printed?
No.
Has it printed? Well, you can. It's all the scale. It's all the scale, so you can actually do it on the screen. See what it says there?
Label right on the triangle. I can't see whatever else it says on the bottom.
Doesn't
Oh,
say,
just
this one doesn't say measure.
Just label the sides of the.
This is the wrong screen. This is the wrong one. Okay, and you're to label the sides of each triangle as opposite. Right. And then measure the sides. Measure the sides of the triangle. The length of the sides of the triangle. So everything is going to be with respect to the angle that is marked. And right.
And then measure the sides of it.
Measure the sides. The angle is already marked. So just need to label the sides with the corresponding letters. That's a bit important. What's the next one? This one? Yeah. Anybody completed number one?
Yes, I did.
Okay, what do you have there?
70, the hypotenuse for the longer line. Then opposite.
Always the longest line on the triangle.
Mm-hmm. And opposite the angle, you have the opposite side.
Right.
And connected to the angle, the line at the bottom, the base, the adjacent line. And you want the measurements now in millimeters?
As I said, it's going to be a rather long and involved process, so
Okay, so just label.
Just label and measure.
Okay, I've measured the first one.
So this is supposed to be an experiment. It's a discovery. So we all have to, it's going to take some time rather than say what they are. So you have one up, you have number one up. All right, anybody has completed any? That's what those triangles, the lengths of the respective sides of the triangles should look like.
Maybe they're not to scale on the drawing on the computer.
You don't have the sheet, so right. It was printed and measured from the sheet. Yeah, you probably stretch it out. Okay. So reading across the first one, we'll see that the fraction of the angles, or the ratio of the angles of the sides are represented in as a fraction. No, not as a fraction. A fraction in two different ways. A standard 32 64ths, and that as a decimal is 0.5 or 5/10. And that is the opposite over the hypotenuse. So I'm looking for. And continuing across. So you all have that screen, yes?
Yes, we're seeing it.
Okay. All right. And you can see. Okay. So these ratios actually are the relationships that we're looking for. The opposite over the hypotenuse is called the sine of the angle that has been marked. And the adjacent over the hypotenuse is a cosine, and opposite over adjacent is a tangent of the angle. Okay. So with the problem that that was stated earlier. What else? The problem. I'm going to go to the problem. All right. The solution to the problem that we had earlier. We see that the problem that we had earlier, we see that the engineer had measured the length of from the base of the ram, and then the height. The 12 was the height, the 12 was the length, and 1 was the height. The angle that we are looking for is the angle that the hypotenuse and the base subtends. So now I want you to express what would that ratio be from the previous chart? What would that ratio be? The angle is at, what would that ratio be? Which ratio would that one be?
Tan.
Right. The angle that is subtended by the hypotenuse and 12.
Tan.
Okay. All right. Thanks, Jeffo.
You're welcome.
So it would be this one, opposite over adjacent, which is the tangent of the angle. Now you have it expressed as a fraction or as a ratio, but angles are most things, we don't express things as in relation to something else. We usually apply or give them a particular name. So in this, the definition of that ratio is actually tangent. So we have the tangent of the angle. Tangent of the angle is 1/12. So to find what the angle is, we need to use the inverse relationship, which is, you know, the conversion of the fraction to the angle, i.e. we go in reverse. That is not something that, you know, we can just do. So we'll need the use of a scientific calculator. I think it's, yeah. So your calculator, does anyone have a calculator? Part of your kit?
Yes, we have one.
Okay. Your calculator needs to be set to degrees.
Yes.
Right. And if you can find the arctan or tan inverse button on that calculator.
Yes, we can.
Okay. So to find the angle, you put in the ratio, which is 1/12. No. And
You'd get 4.763641690.
Okay. So in any situation any real life situation where we have triangles, which maybe you all can help me out here. But where do we find triangles? Bridges. Anything else? No. On a track, a race track that is banked, roads that are banked. So we would be able to get the relative distances, but we would have to use our trig ratios, our trigonometric ratios, to calculate the angles. And these angles, these angles would be mean. In some cases, they need to be to specifications, like the example we just had here. So that's why we need to know the trig ratios as well as how to calculate the length. The Pythagoras theorem, we need to know the trig ratios and the Pythagoras theorem in order to have all the pieces of the triangle. Okay. Okay, so the next class, we'll be looking at what happens to these ratios when we change the angles. So and in closing, can you complete the rest of the problems on your worksheet and determine the angles for the next class? Thank you.
You're welcome.
Okay, so what is the consensus now? Are we going to discuss the grades and the lessons, or what are we going to do?
I don't mind getting mine, but the others, some of them are not there, so I don't know. I cannot answer for them, but I can answer for me.
And I would like the discussion because it would help with my evaluation exercise, because I need some feedback.
Okay. But your evaluation, but when you think about it though, your evaluation should be about you and what you think. It shouldn't be influenced by us. Really.
Yeah, I know, but still, I just wanted to, you still need to check if things are right or wrong.
All right. So do you want the grades? Are we agreeing for me to just tell the grades? Or can I tell?
Sure, I want mine.
Okay, so you don't mind if yours is, okay, Jeff, since you want to hear yours, I'm going to say yours out loud. And and only the persons who
taught. Can you just remind us what people taught, like what?
Oh, Jeff, I didn't mean. All right, Jeff, you got 9 out of 10 for your teaching, and the reason why she got 9 out of 10. Let me look at the things that the different things that are grade for. Sound math content. Almost everybody got that in terms of were we teaching correct math? You know what I mean? Do we have were we passing on any misconception and the wrong ideas? I think only one person lost half mark for that or something, but I'll check again. Suitability of a task. That is just for 1 mark. It's either the task suitable or it's not suitable. Then I was looking at for appropriateness of teaching method. Are we including, to what extent are we using it? And this is the main problem I'm seeing with the lesson. To what extent are we using a student-centered approach? Are we really standing and giving instruction? Are we, even though some of us have some nice activities, but we were the ones doing the activities and the students were not really engaged. Now, as long as I am the one doing the activity, my lesson is teacher-centered.
I'm just going to say though, that in this setting, we don't have students. And if you notice, sometimes you ask questions, people are here working on their presentations, they're not responding to you. So when you're planning your presentation for only 20 minutes, you have to factor in that you have stuff to cover. You're feeling upset. You're not going to be standing there asking, is anybody working on the problem? Nobody's working on the problem.
But it doesn't have to be a problem, because even the fact, but it doesn't have to be a problem or something. But the way you build it, you have to. So I'm not going to accept an excuse, I'm sorry, for not including activities for tactile people. I'm not going to accept an excuse. That's my.
But can you, how many learning styles are there? like 8 or several.
That's
right?
intelligence based.
Okay, but there are many learning styles.
There's 3 learning styles.
What learning styles?
Tactile, audio, and visual. Those are the 3.
Okay, so in LSE you have to have all 3?
That's what we're
in every single lesson?
That's what I'm aiming for. That's what we should aim for.
And everybody else had all 3? I'm talking about myself because I'm really not satisfied with my grade.
Well, I know I was sent to teacher centered. I know that for a fact. I know that. Because I mean, I was asking questions and stuff, but at the end of the day, when I looked at the content of what I presented,
you're teaching teachers, you're
the
going to
content.
you're going to come and say, do this, and nobody's going to do anything. It's not like your students say, come and do this.
But at the end of the day, with the content of mine,
me too, but I didn't do
it.
And I really don't agree.
Yes.
Anyways.
Yes, continue.
And so one of the reasons, so for example, so Jeffrey, you lose your mark for the timing. That's all you lost mark there for. But the content, there was no miss in terms of no miss.
That's fine, miss. I suspected that would happen because we were having, remember I told you we were having trouble with the technology at the center.
All right, and the plenary activities, I wasn't seeing the plenary activities. I remember we spoke about these things. Suitability, look here, let me put it like this, quite simply for everybody to understand. Now, the purpose of this course is not for you to come here and stand on the board and teach. You don't need this course, or you don't need a program like this to stand on the board and teach and give instruction. Anybody with math knowledge can do that. That's the point I'm making. Are we understanding that? Are you agreeing with me with that? Once you have knowledge of math, you can start. There's a difference between a mathematician and a math teacher. There's a distinct difference. A mathematician can stand on the board and explain something to you. A math teacher needs to engage learners. That's the difference.
One issue I always question, because I agree with you and I've heard this before and I agree, but I always question like student-teacher ratio. Like when you have 40 students in a classroom and you're going to be trying all of that and you want to have everybody engaged and so on because, okay, it's really from a case of experience. My little brother complains, transition, he's in grade 7. He was complaining that he's in class and he never falls asleep in class. And he said, I fell asleep in class. And he's like, he used to draw down the whole world. He will draw me in heels. And I'm like, why is this child drawing me? He says, I hate art class, so I'm writing notes. And that's not art. And I said to myself, I somehow kind of pinpointed because he just complained about that the other day. And I say, you're falling asleep in class? I'm like, you can't make your parents know that. And he's like, well, Dina, I know it already, and you're not giving me anything new on the board. I can look at it and just, I can look at it and I get the answer, Dina. It's boring. And then I think
because are not engaged.
Someone came here and spoke about it, about his daughter and how his daughter got involved in drama, and my brother got involved in choir, and then he kind of started calm down. Because he's like, the classes are boring. I'm not doing anything. And then when I go to art class, we draw mid-write notes. So that's when I said to myself, it's true, But then I said, come on, look at the other kids. Come on. He's like, well, they can be doing the question before some of them. Some not done. I'm like, but still, you have to wait. Not everybody going to finish it. So it's those things I look at this and I said, the student-teacher ratio, you might have 10 students who finish the question in a minute. But then the next 10 finish it in 3 minutes. And then that's what I look at and I say, probably that's the thing. The ones finishing it in 30 minutes, they probably need a little thing that's a little more, I don't know, maybe every 3 minutes. Like, the fifth, what you say?
This is why, it's when you're doing, the idea is that what we're pushing is what is called differentiated instruction. And differentiated instruction is really understanding that even if I have 100 students in front of me, they are all different and have different learning needs. The problem is, this is a major problem, when we have our students in our class, and most of our lessons are audio visual. So we are really meeting the ones who can hear by listening and the ones who hereby see. Would you agree with me? So most of the time, the students who underperform in the subject are the ones who are tactile. And the point is, we're not meeting their learning needs. So sometimes we send them to micro-practicing and blah, 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 because we say they're slow. What happened when they get to micro? They exceed the others. What was happening? We weren't teaching them according to who they really learn. We weren't appealing to their learning styles.
Ranking students in a classroom, you think that will help? Like when they do the ranking and the students, when you find that probably the ones in 7-3, you know, they're dots according to people, which I hate saying, you know? Do you think those, okay, if you can do a little survey or something to find out if they're tactile learners, how did you really?
The issue is this deeper than that.
Yeah.
But, yes.
I'm not talking about it.
Yeah.
I'm not sure you know, want to get feedback so can.
Yes.
That same time.
But basically what she's saying is basically exactly what I'm saying in terms of the idea is this. Sometimes screening students, putting them according to, depending on what we use, what subject area do we use to screen students. That's another thing. So there are so many issues that we have to look at when we're screening the students. But the idea is, guys, we have to try to meet the tactile learners. They are the ones who are often left behind. One of the reasons why I came here, and as I can see with the context of the course, I couldn't introduce you to everything. But the idea is there are things out there that can enhance our teaching. So go and look them up. Some of them you're exposed in this course, but the fact that you already know that things are out there. You can go and experiment and see what else you can find. Agree, disagree? Because there's no way you will not learn everything here. That's impossible. There's something called a learning to teach continuum, where you get to an extent when you come out of teacher's college, but as you leave, you should be excelling, you should be learning more because you should be doing research and getting abreast with new technologies and new things coming up. My biggest, as I said before, so my biggest disappointment with the teaching is that some of us, for example, I'm going to use Ricard and hope that he doesn't take any offense.
Excuse me for anything bad.
He has nicely laid out activities, but guess what? He was the one doing the activities. Do you understand that? So when he had the graph thing up there on the board, so when you're there up there in your own euphoria of teaching, what are the students doing? They could be throwing stones for all I care. They could be sneaking out of the class because they're not doing anything. They're not engaged. You're the only one who is engaged when you're up there using your nicely whatever. Now, when you look at a lesson, like I think it was Anya who used that triangle and have you work. When you look at that, you were always engaged. You were doing something. When you look at Jeffa's lesson, she put the thing that she did the main activity, she put it on a number line. There's several things, so you don't get bored. You're catching the visual ones, you're catching the tactile ones, you're catching everybody. So it's not. So I'm not understanding. It's not something that is impossible, that is undoable. It's just that we have to have an open mind and start thinking when we're going to teach. Am I just reaching the usual or the visual ones? Am I just doing the usual? You know, and that's nothing great. Anybody can do that. Am I just, if you understand what I'm saying? Now, saying that, and that some persons, because for me, some persons got an A without even, got a 9 out of 10 without me even thinking twice. Because the main thing for me, are you reaching everybody? Are you trying to reach everybody? Was it a student-centered lesson or teacher-centered? Because the idea is to get you teaching from a students in a perspective, not standing up and do the same thing that we see in the traditional classroom that we're trying to move away from. And for those of us who live in Jamaica, if you look at it, go and look up the 2013 math policy and see what is recommended, what is needed of you as a math teacher. Go and look at it and see what is required of you. Go and look at it, because these are the very things that we have in the classroom. Sure. So,
Miss,
yes.
Can I know mine, please?
Who is that?
Colleen.
All right, Curleen.
Mine as well.
All right, so Curleen, you got 7.5 out of 10, mostly because you were teacher-centered again.
What about mine, Sabina?
So look here, look at, let me tell you what I give you a grade for. Let me tell you exactly how I grade you so you all can know. All right, so for sound math content, that's 2 out of 2. Most person got that. Suitability of the task, most person got, I just like, I don't even think about it. I just give everybody that 1 mark. Appropriateness of the teaching approach, that was marked out of 2. For Carleen, I gave you 1.5. Why I gave you 1.5, which I think is generous, very quite generous, was because it was teacher-centered. Full stop. Very, very teacher-centered. And math, and the next thing is the math thinking. That was also marked out of 2. Now, if your lesson, let's think about this. If your lesson is mostly teacher-centered, we're standing there telling, there's not much room for getting students thinking and eliciting reasoning skills. Agree with me or not? Tell me if you agree with me now.
Yes.
No? There wasn't any, so when your lesson is teacher-centered, the math thinking is going to fall also. Because you're not pulling, because you're just giving out information, you're not pulling from the student. So one really impact the other. So Carleen, I also gave you 1.5, which I also feel that is very generous. And math thinking for the timing, Carleen, I'm not being harsh to them, I'm being kind. Carleen, you went over time, so you lose that mark, and you went drastic over time. So you lose that mark. All right, so.
Yeah, what about me, Sabina?
I'm coming, I'm trying to meet everybody's needs. Give me a second, please. 1 second. Okay. All right. All right, so for most of the persons who got 7.5. All right, who am I looking for?
We're missing 2 marks, yeah.
We need 1 more.
Yeah, we're missing 2 marks.
1 more again.
We have math content, suitability approach, appropriate and teaching approach, math thinking, timing.
2, 4, 6. All right. Math content, that's 2. Yeah. So that's 2. So that's 1.
3.
Appropriateness of teaching, that's 2.
5.
That is 2.
Right.
Yes.
So 25.
Math thinking is another 2.
7.
And then the time is 1.
8.
That's 8 to mark it out of. Then I multiplied by 10.
Okay. So you mark it out of 8.
Yeah.
Okay.
All right, so who is next?
You please.
Alyssa.
Yeah.
Sound math thinking, I gave you 2, which, yes. Suitability of task is 1. Appropriateness of teaching, I give you 1. I gave you 1.5 out of 2, which I think your lesson was extremely and very teacher-centered. Math thinking, there wasn't any room for students to think. I gave you 1. And for the time, because you never really went over the time, but not so much, I give you 1/2. That's it.
What time is that 1?
It's not 1, but sometimes I use my discretion to give, because almost everybody went over the time. But some persons, just a little bit, so I said, all right, let me give you 1/2. But some person really exceeded the time, so I just like 0. Ricardo, you saw yours already, I think. Okay. All right, so who is next? And that's, she knows hers already. So who is Diana? Where are we
there?
All right, Diana.
Yes, go ahead.
All right. Diane, you got 8.
You were very generous.
No, I was very generous. I don't need to go through yours. Good. You got 8 out of 10. Who's next? Anya? You got 9 out of 10. I think that you lost your mark for timing, but I think your lesson was extremely, I have here a lot of accolades. Very good lesson, good activities, the students' work. It was very activity-based, very good lesson. Also, I think that Jeffrey, you did a very good lesson also. It was very active in the debate. The students were.
Thank you.
And even your prayer model, I was very touched when I saw you use that. So you can, I'm saying, you can see if we're fair, we can look and we can see the difference in the lessons in terms of student-centeredness versus teacher-centeredness, if we're really fair. Tasha.
Thank you very much, Miss.
Tasha?
She's coming, Miss Chen.
Okay, I'm not going to call her grade if she's not here because I really don't want to get. Who is that?
And she comes.
I'm here, Sabina.
Sabina, I called you grade already?
No.
Okay, you also got 8. And I think you did a good job too. You just lose that extra, it's just half mark you lose. That's why you never get the 9. So really, it's just half mark. Half of that made a difference. All right. Anybody else here for the grade? Oh, Dana, I'm sorry, Dana. Dana, you got 7.5 because you're the teacher center.
Yeah, I know.
Yeah.
Yes, I know.
Yeah. And I think that I'm marked extremely generous, I do believe.
Yes.
Oh, I can tell you that you get 7.5 to because you were teacher center. So basically, I have, and in fact, I think that I wanted to take off another half mark because I was thinking through, like, I said that the activity was a very good, like the building up of the lesson, the organization was very strong. So I was thinking it, like, you know, but then I said, let me give it the benefit of the doubt.
Activity.
And I think another thing for Alyssa, another problem that I had was the development of the lesson. Because I feel like, I don't know how to put this. Yeah, I think that you just did talk too much.
Yeah, because I was there saying, I tried it, I was there saying, oh, I tried coming because he's like, Lila, you're not doing it. You're not doing it. Like,
no, the content was heavy. The content was heavy.
Yeah.
But it was very, like, you know, very serious.
I was there saying to myself, you can't teach the whole manipulation of the multiplication thingy in 20 minutes.
Because sometimes the pace too, like what if we're teaching this, we don't want to be teaching everything. All of it. So all of those things that I would take into consideration and decide, like, do I give her you know? So that was kind of, but the content was heavy, man. Really too, yeah. Yeah. I'm happy that you're there. But it's not that, I think that we all, I don't say that we all have the ability to be good teachers because our content area is strong. As I said before, all persons got 2 out of 2 for content. Maybe I had 1 person who got less. But we need to pull away from, I understand that is our history, we need to pull away from that. Basically.
You were saying something else I thought on.
I think the organization, if I didn't understand, like, I couldn't say I built a nice little build up. If I never understand the idea of, so let me ask you, do you think that if the students didn't understand the idea, if they didn't understand the idea of higher purchase, would they feel like they would walk away with something, like a deep understanding of it? I want you to answer this question.
I do.
You do believe so?
Yeah. Honestly, I do.
Okay.
I mean, if I had time to discuss with them and if we were having a discussion, then
no, I'm talking about, but you can't talk about your time. If we're thinking that we're planning at 20 minutes, so let's think about this. If we're planning at, yes, so you're planning a micro teaching activity. So in that given time, and with what you're presenting, do you think that the students will develop a deep understanding of the concept of higher purchase?
If I was teaching students who did not understand, I would have probably go yes to that.
But that's the point. It's for me now, I'm seeing a big connect to say, if you're teaching slow learners, they would walk away. That was the main thing I picked up on, to be honest. So when the teachers I'm looking for is, we're assuming that everybody don't know. It's because remember now, if you're teaching this, you're assuming that I don't know the content already. So I didn't get that. It was like, okay, you're pulling from me because we know already, so it was easy for us to relate. But I really didn't feel like the students not being exposed to the topic, they would have walked away and be able to say, yeah, man, we understand properly, and yeah, man, I could ask them certain questions and they could relate, and didn't get that. Okay, so so that is my.
I don't want to ask you, like for instance. And
I'm not trying to be mean, guys. I hope you understand. No, not you.
Like for instance, okay, I did simple interest. If you get 15 minutes to do simple interest, right? I know you're not going to be able to cover every single thing, but that 15 minutes you probably could just have used it to do like a piece of the first part of simple interest. Then you never really have to cover every single thing in simple interest. So let's cover a little piece of it to make them understand.
Two little activities, two little or three little nice little simple activity. All right. So even with your lesson there, you gave a scenario, and once I gave the scenario, you went into defining so the whole build up of the lesson. You went to defining what simple interest is. My perspective. What did you do? Remind me. Higher purchase. Sorry.
I did higher purchase.
Yes, but I'm remembering.
Yeah, man. And
because you just did it.
Right, and I gave them the money with the car. So they have deposit plus installments, and they gave me that. It was that.
All right, let's go to the PowerPoint. So quickly before the concept was built, so this is the thing. Before the concept was built, the definition was coming. I was like, for you to build the concept and then ask this. All right, let's do this now. So Ingrid kind of did that too soon too. So you realize, Ingrid, yes. So instead of asking students, give them the activity and let them tell you what it is. You don't tell them everything.
So then they told me that you have deposit plus monthly payments, and then I said, okay, here it is. That's what you said.
Where did you do the definition?
It was right after we talked about each, and then I said, do you guys know what this is? So there's some method. All right?
So the concept wasn't built yet.
Thank you.
The second was great. You give them the activity. You understand? After the several activities, you said, no, what you've been doing is perimeter. What do you think perimeter is? So that's build up. You know, that's it. So all you organize this problem. So probably have the content was strong, but organization, the fellow man that really, so it gives gaps in all the rest to come across. Ricardo, I really love the activities that you had, but gosh, you never leave them good. They really make you teacher center. But even that activity with the boat and the treasure, did you see that activity? That was a very good activity. And even the tape thing on the boat. But give the students, let them do it. Why are you doing everything? But you don't have to hear. You didn't have to do everything. Let me tell you what you could have done. So you need to take time. You could have done that thing, let them do it, and you're doing the convert thing. So all you're doing is the content and talking. That's it. That's all you needed to do. You're trying to cover too much. It's 20 minutes.
You know, so I didn't tell him that you can't follow my answer.
So you now have some issues with it. Because I wrote it down, let me tell you. The questions were vague, yes. So I think I was too generous with the score. But anyways, the questions were vague, and the language, because you were mixing up number line and CAR-T, so the language was really, the math language was really off. All right, anybody else? So we're gonna take a break. Get back an half an hour break, get back at 6, and then I'll give you a quick activity. And then I'm gonna give you something to research. Everyone looking at me like I'm crazy.
Miss, I was not even looking at
that one.
Miss, how you said everybody said Daisy. You know,
All right, so take your half an hour break. All right, and if everybody's now satisfied with their score, any issues?
Thank you. Yeah.
Online persons are satisfied with their score, any issue?
No.
No problem.
All right. So what you're going to do now, you're going to take your half an hour break, then we come back at 6 o'clock. All right, and I have an hour. I just want to give you a quick activity, and then we wrap up the course, and then I tell you, I want you to know, even though I didn't get to touch this, virtual manipulative, go online and search for them. They're virtual manipulative, there are things, so you can use them in your classes. If you don't have the actual thing, you can use these virtual manipulative. So you're going to explore, so just go online, practice their tutorials, you can practice how to use them. I just want you to make you aware of this, okay? Yes. All right. So we'll come back at 6.
This was on your right? So I don't have my just don't so I don't think I can just say so if I'm doing Even that time to think, because there's different things. Think here, all right, think about this. What do you think? All right, tell your neighbors, think about it, think that. So even these structures are like thinking time. When I give you what you want to think about it, so sometimes I wear up here and I look around there and I see that they're not. So I give them time and I give out anything and they're the one that comes out. I think so. I can't entertain what you're doing here. What I see, you're not actually doing work. It's not that they're actual students that I can see. Come on. What do you think about this? What do watch the video.
For me, the figure is that even the figure there, but it was still how to calculate siblings how we or before it, because it's like a reflection of the entire lesson. You never build on the lesson. It's so, I don't know what it's but it's so, I understand it's a subjective thing, it's not like yeah, I'm saying, but the point of it is that like I was extremely the color moves all the other that's like it doesn't have to be formal, but what did the students do? They need time to do something. What are the questions? How do they really stop to think? You're asking questions when they just tell you. If you ask a person that doesn't have to think, and you're going to answer, I have to think and tell you. It's just like over here, you know, one of the things that said to me, they have to think. You understand the point of the output? They have to think. They have to think. You cannot be a person where they're going to have to tell you. They have to think. I think I would be, I think I would be there only 8 marks, like 4 or 5 categories. So it's 10%, and remember, you less than at least 40%. You less than take lesson plan is 10, the teaching is 10. I don't want to, so there's so many marks and to get. It's just 10, the evaluation, the reflection is 4 or 2 marks. So I guess that I don't need to understand a lot of marks. So what about progress? What about cohesiveness? What about flow? None of that can be marked for. I mean, and also I say teaching. I can go and shuffle, but I don't know. It doesn't matter. It doesn't for me. It doesn't matter. It's fine, but still, but all right. I don't know. And this is, I said it, no, there's a nice thing you can get yeah, something you know.
Oh shit.
You can download it, you can use the it's not very expensive. Maybe because I have a somewhere here. But I assume that it was free. Yeah. To the next semester. Yes, it will definitely. Let's take a project to see now. It is not like, it is just a software. I know, but for you, for your purpose, for what you need.
Because I do you say about
No, exactly. The example, I mean, demonstrate and show the thing what to do. And they're heading to the meeting in class and before the meeting, this and that are self-confidence. And probably after use of something and they will reach it because of what they have. And they tell me, like, doing it next time, you can ask them to do it. But probably one of my things, but sometimes I actually do it.
I know.
Because that was the rule that I never want to that because of the whole experience of doing it so much that it can teach us that I feel doing it so demonstrating, having a discussion with the and then see check everyone and then give it some good for that. This and that. But I mean, they're looking into it. I think activity was.
You know what I don't understand? Like, for example, what does that make sense? She seems as a great thing, and he's as a great thing. But so when I put it out there, to say the impact. So it's deeper than I create. And I don't want to go for your presentation. I don't think I'm going to teach. I don't think I'm going to presentation. I'll expect you to do it. You do. Huh? No,
I mean, because I mean, before you know, there was a whole version of let's say Twitter. I'm not saying no for huge.
I think that's not going to so fair.
Maybe so, what could you comment? I think we should have probably rushed with the money and the seats at the hour with more seats at the rush with the money. That's a critical.
Time.
Teachers in our environment so as a researcher, competent people are certified. Our goal and city goal will be to certain because of McCarthy. So I mean, you know, there's I mean, because most I mean, important buildings and most coming up with McCarthy and all the experience and all that kind of stuff. So, I don't just do what is the opportunity to get away with us. Each time each class you go, have a lesson, practice the
That's how this course is supposed to be. You have a teaching all the time. There's no, because if there's no time there, when you learn something, there's so many wrong things that we have to recognize because even today we don't stop it. It's many wrong things in our kids. There's so many wrong things.
I'm teaching so many things at one time.
No, man, I can check. It's just good.
No, I think you take one.
No, it should be fine because inequality, depending on what it is, inequality factor that go at every end. Or that is very upper level. That's fine. It's different science school, but it's
journal, at least minutes, over at least or company, which are there's one person that can see and service you. Notification and enforcing that.
it's support. You don't understand the purpose for 3 minutes. There's so many things for there's no way I can put your presentations because I am in that point of presentation of text. So in a street class out of the 8, that's 2 days of presentation, and another day of text. So that's 3 out of the 8 classes that I look at last week, really for teaching. And as a week, you cannot try to push certain people because it's 50 hours a month. You can push certain things. I'm not straight. There's no way to take so much ideas. Someone else wants. When I was a teacher, which was I went to my graduate and what can I show you? You know, and speak, and the feelings of the like I feel like this is a thing. I feel like because of my yoga show, with the extra coming to want to face. It's true. I think it's just my age at the time where he moves really good. He said that, like, he uses this idea that what like this, like, you know, those, everything happening. So, that's why I asked you, like, I don't even understand the rationale. Yeah, that's the rationale. I'm not for the chance of anything should be.
Well, I think it's a local project or much we will need.
Thinking because, and you have to think very strategic.
I'm not going to go I'm not going to judge German. Just like I'm always around.
But other subjects, that's how we determine. Let's think of the night before I read something and get it. But he said to me, stay late because my people all of the subjects. And then I go back. And the mechanics, and the people don't know when I want to push up on the street and what the Lord. You got terrible. Terrible. I make a call.
I see that everybody want me at my stage, but I think when I'm
what is it, math and what is it? From math so how you end up with the discourse?
Because I'm a 40, and the politician who was just voting and still same stuff like and just teaching go up and say, do voting. So I said, oh, that's right. Because I'm a politician who from here, so when
you have to get degrees in but they don't accept it. Any leader. It is. Yeah, no, because see, they're in math, they can't secure the school. In 2 years or more. So, availability is really easy to get in. I mean,
like when you say, from the school, master, I come second one, and really, but it's like a profession with them.
Yeah.
Because I think that if you are looking to teach us,
that's true.
so I think it's not like.
I think, well, yeah. You should do another year of getting into the funding.
Yeah, anything. I was not email. I don't say anything.
But it's hard to it's hard. But if you do this, be careful and download it with what is set up the second year. Yeah, man, I'm sorry, no, man, you are different, no, man. I think I'm here for mixing the house. Where are the others? I don't know. It's 6 o'clock. Is it 6 o'clock? 6 o'clock. So what? Anything satisfactory?
I deviated so far from my lesson plan. You're not going to compare it, right?
I'm not even surprised because the thing is this, all the pieces that are named after good quality because they so I think that this is the only thing that's about home. So this is the that's why I think also financial because it's just in case of falling down.
I think my lesson plan is far superior to what they want to do there because all the management they've done all this stuff and what should become it's all there. But participation was zero, so
but look here, but you see, you don't want this to participate. You each have design, so you have to think through. Okay, one of them the same things to get them control. But the students here, they have broad things, so at least they have theirs to work. So you have to think through, like, students, like, students are always students, doesn't matter what they make. They're not always the students. It doesn't mean to the students that as for carry this. They're not going to take it. Let me give you an example. I told you, computer training, laminate them, blah, 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 and guess what? It was nothing. Because it's my student, as I said before, I was the switching of the button next door to close the class. Because what's your student would have to be the students, and the same kind of thing, it doesn't matter what they're doing. So you have to think, like, if they don't bring it, what am I going to do? Especially when they're graded.
I guess I'm just like, I'm happy that so yes.
Did you fail?
No, I'm good, but discussing something. It's not a pastor.
I know. I just
To tell you the truth, it's not great that word either. It's not great that word. I need the end. I'll just be stopped. It's right there.
No, I know it's like passing. Yes, everybody wants to pass. Nobody wants to fail.
And I don't want to just pass too.
That's what I'm saying. You see, grades and grades don't. Grades used to be like high school grades was a big deal. But what I want to do is that if I'm in grade, just like quality of work.
We're here.
Just me, quality of work. If I'm doing something, I'm slow the quality and the grade, all right, it looks like, okay, yes, I can be held accountable for something, fine. It's got to me a little bit.
And for me, it's very important because I'm sending all the teachers. I'm preparing teachers, and it's a profession.
And the quality of output. I can't say that. Quality of output.
I was saying to somebody today, so they told me, like, I never remember, blah, blah, blah. And I said, how would you feel in the doctors that they don't remember surgery? When they have the confidence in your doctor in the same thing, the doctor can just focus on their things.
Yeah, and I mean, just like some doctors, it's just like some doctors, like, they might have a gynecologist who wants to.
I think
it's how the profession goes.
exactly, and that's what we change.
People doing that something that optional, that's something that,
and that's the same what we do.
It's treated like, that's why I'm saying quality, the grade, yes, it counts to pass and get a good grade, but you want quality. That's what you used to love it. That's what you used to love in your school.
Where's the markers?
Miss McCarthy, I'm here.
I see you. You want to talk to me?
Oh, I thought the internet was dropping, so I thought you didn't hear.
I wasn't hearing you.
I'm here as well, and you.
Okay. All right. So we have.
Does it matter if I put 5217 or 52Q?
Hi. I'm coming. Let me get this. Okay. All right, so I have here, so I know it's the last class.
I'm back, miss. I had some issues with my internet.
Oh, who's that? Tasha?
Tasha here.
All right.
Yes.
So I have.
What?
You were saying something?
No.
Okay. Tasha?
Yes?
Are you hearing me? Okay.
I'm hearing you, miss.
Okay. I have some activities on the board, 2 activities on the board. I know that it's the last class, and so you might be wondering why I'm still giving us work, but I still want to maximize on the time, all right?
Have you given out the grades, miss?
Oh yes, Tash, oh, you weren't here. Oh.
Sorry.
Tasha, I don't know if you were here earlier.
No.
When I was calling all the grades and telling that, I hope you guys, I didn't call it yours. If you weren't here, I didn't call yours.
Not a problem.
You guys don't have a problem with me saying out what the grade is?
No, I'm not.
All right, so I'm gonna go through. Okay. I'm coming. I'm searching for your Okay, Tasha, you got an 8 out of 10.
Okay.
You sound like you're not so comfortable. Any issue?
I just wanted to know my weaknesses.
Oh, I think that even though you were very energetic, Tasha, you are very, very energetic, and you really, what is this? Full of spirit, very spirited. But at the same time, I want you to realize this. You were doing activities, but you were doing it on the board. The students were not doing it. Can you tell me what activity did you give the students to do? You were the one putting it on the board.
Yes, but I also had to the students to create problems based on the information on the board.
Yes, and that's the reason.
Also answering oral and written questions. So.
Okay, so that's the reason why you get an A. That's the reason why I got 8. That's the reason. But the point is there were.
Okay.
Yes. The point is there were little things, like for example, when you are doing the color activity, instead of you doing it, why not allow them to do it? You understand the point I'm making? Why not allow the students to do it? Give them little things or tell them what it takes so they could do that activity, all right? So they could do their own little things or give them little. So the point I'm making, Tasha, we want the students to be working, not the teacher. Do you understand the point I'm making, Tasha?
Yes, I am.
Yes, so maybe like an activity like that, you could give them, like even though you could ask, you could carry some different color things and ask them to do a little tally, give them each person a handful of different colors, and do a little tally, so they're the ones counting off, they're the ones doing up their little tally, and then ask them to translate that to a bag, so they are the ones doing that. How many did you get? How many of this did you have? How many of that did you? So instead of you doing this survey and this activity, get the students more involved.
It was a guided activity.
But what is a guided activity though? Because if you're the teacher who is doing it, then it's teacher-centered. But if the students are doing, because what we're trying to move away from, Tasha, we are supposed to get the students to do the work. So focus on that. Even though, yes, because we're trying to move away from the traditional approach where the teacher is a stage on the stage. The teacher is on the stage. We're trying to get away from that. We're getting the students to be on the stage, meaning that they're the ones doing the work. They are the ones. So it doesn't matter what activity you have, you find a way to. So what you should be doing is, all right, the guided discovery that you're saying, or the guided activity that you're giving, is giving the instruction for the students to do it. So all right. So how many of the blue do you have? Check them. How many of the red? Could you tally that and could you record that? This is a guided activity, but I am not doing it. The students are doing it. So they're always engaged. And then if you're seeing a difference in what I'm explaining.
I'm getting you.
Okay. So think about, that's the point I'm making. Think about that. Getting the students to do the work. They're the ones who should be working. So your job is basically to guide them. So you're guiding, not doing, guiding. All right.
Thank you.
All right, Tasha.
Hi, Sana here.
Yes, Sana.
Yes, I wasn't there when you were giving the grades.
Oh, really?
Yeah, well, I was connected, but apparently I was not there.
Okay, Zana, you got 9 out of 10, and you lose a mark for math thinking, but because you were within time.
All right.
Yes.
Okay, thanks.
9 out of 10.
Thank you.
And that 9 out of 10 is really just a half mark difference that suggests some of these marks. Because remember that.
I didn't get that.
Never mind, it's not that important.
Oh, okay, yeah, no problem. Thanks.
Are we finished with that mark? Are we finished marking?
Not yet.
Do you understand what is expected?
I think so.
Huh?
I think so.
Do you know what to do?
I'm trying.
Are you teaching this?
No. Okay, even us.
Keeping alive, you're alive?
Yeah.
6, 7, 8. I have my first class. The connection. The only one I do today. It's like he's got autism. No, but I listen to him. He's just yeah, you use one. It's not sometimes review. No, it's on the safety website. It's on the safety website or the reports. Safety website and the ministry education, but ministry education is not, so it doesn't give you. It has like some words, like reports and stuff, but then pinpoint challenges. I don't think ministry education pinpoint challenges, which is what it had.
You see the pinpoint points. That's what I want.
Just what it is in my life. She said this for the first 4 years with you, and then it's not the same say for you one. Pinpoint how you love. That's occurring. No, she's a one that's occurring more. I went to go more than once. When we come in, so I suppose it's in 1 year, you have to see that, and then again. So she was she like so
The second one is linked to the first one. Yes. So if you can figure out this, you probably can put a pattern in there.
I just saw it. That's what I
You finished now?
No, the first one, I finished. Let me see. So look at the other.
Miss McCarthy? The second question, I'm having difficulty reading what's on the board. The second one, I cannot see properly.
You're trying to finish number 1 and number 2.
Yes, Jafar, I didn't hear you.
The second question, can you read it for me, please? I cannot see what's written.
Help students to derive the formula for sum of interior angles of a polygon. Then again, okay, and again the formula 180 times n minus 2.
Okay, thank you.
How would you help students to come to understand or to derive this formula? How would you guide them to do this? No, I mean another one. Here. It's not a bad thing, you know.
It's not nothing wrong with myself, please. No, she didn't say. We just have to make sure it says self-numbing first time.
No, man. You know how some people are so boring, like, you know. No, I don't. Some people like her when
Then just look at the store down. Sometimes disgusting.
What is the end of it?
I just
so usually it's given an eight. We already got it for the triangle. One triangle, it gets in the pattern. Quadrilateral, 2 triangles, and one is the triangle. It's not how many sides? One side, how many triangles? So after this, we can do a table thing there, and it's important to see that pattern thing there. So I'm going to give you a little hint, because they get to the hint. Finish working or still working?
Finished.
All right, so I'm giving bonus students some more time. Tasha, finish. Anya, Where am I still?
Yes, I'm finished. Anya is there.
Okay,
Yes, I'm finished.
Are you finished? Carlene? And Diane, are you finished?
Yes.
Okay, all right.
No.
This is but we're not using alternate. Oh, very. I know. I was just. So that she was so. She was so. The one at the top. The one that said you should. I'm gonna try to send me get from the top. No, coffee. It's not. No.
I would have one.
Finish. You go to first.
I'm presenting.
I'm presenting. You want to present your solution item? Was he working on anything? Or no, you're going to present?
Are we finished? Okay, so 5 more minutes or what? 5 minutes? 5 more minutes?
You know, I was here thinking about having them find all 5 angles equals.
What is the 5 angles? Interior angles?
Just I was looking for like them finding all of the 5 angles.
I'm not sure I understand.
Like,
oh, the individual one each.
Yes, ma'am. That's what she What is the time streets?
All right, who wants to present?
I'll do number 1.
No, you're doing number 2. Only because you scream so quickly, I'll do number 1, so you're doing number 2. Who wants to do it? Anya, do you want to do number?
Okay.
All right.
Sure.
All right.
Okay, so to show that the sum of the interior angles of a pentagon is 540. So what we could do is take a piece of paper and ask the students to create a pentagon. It doesn't have to be a regular pentagon because a pentagon is any enclosed shape.
Very good, but how else could we, instead of using a sheet of paper, what else could we use?
The tangram pieces? The what?
Geoboard.
Oh, the geoboard. Yeah, the geoboard.
Plastic band.
It already has the point, so it'll be easier. Yeah.
So because
that's true.
So that's I see where you're going with that. Was a very good point. Sometimes they have the to draw that 5-sided figure. Some of them have a little bit of challenge, but if you give them a they can
geoboard.
Yes, or even the grid paper, the geo paper. Sometimes it's easier for them to draw it. So
yeah. They have to know that it doesn't have to be regular. So I want them to see that is not only regular. Yeah. So what they could do is just cut out the peaks, the vertices to get those angles.
Yes.
And what they could do is to arrange them, like make all the vertices meet each other. So what they will see is that you would make one circle and half of a circle, so that's 540. Like how you do with the triangles to make the line. I can't explain it. Like if you take all the peaks, right?
Peaks?
Uh-huh. And you can take, yes, listen, I'm listening.
Yes. I see what you're getting at. I need to explore it. Does it work all the time?
With all of, because all of, no matter what type of pentagon, it will be 540.
It work all the time? We'll experiment. And I've never tried that one, so I need to experiment on it.
Okay.
Yeah, I need to experiment on it.
Okay. But they have to be careful, because if you have because you know you could have the inverted, well not inverted, but the obtuse angles. So they have to be careful what's the interior angle.
How do you estimate it though? Because if we combine them and it's almost form a circle, how do you accurately estimate it? Because that's what I'm thinking of.
You just make all the peaks meet in the center. Yes. It's like what we do with squares and rectangles to show that the sum is or with triangles to show that the sum is 180.
Yeah, but that is easy.
Because they form a straight line.
Because that one forms a straight line. So that one is easy.
Uh-huh.
And for because it's 360, which is a complete, so that one is easy. But the point I'm now making when it comes on to the pentagon, it's 540. How do you estimate it? Because I understand what you're saying, and I'm trying to figure out, does this work all the time?
Right. Some will make a circle, but the rest now will make a straight line. So when you combine the 360 with the 180, you get 540.
Good.
So that's the sum of the angles.
So I need to, yes, I need to explore it. I need to go and look that one up. So good job. That one.
Okay.
All right. Yes, I'm saying it can. Yes, man. It's a, because we did that. I know the one with the triangle. I know the triangle and the rectangle, but I've never done it for a pentagon. So I need to go and do it. So for the triangle, you know, because all the angles when you fold them, that give you a straight line. So that's easy for you to see what's the straight line. Are you following what I'm saying? Yeah. Give me a second. I need to do a quick demo over here. Yes, and the edges, if you tear them off and you form a straight line quickly, you can experiment with that. You don't need to tear it off. So. And you can even try the quadrilateral. You can even try the quadrilateral. Those are easier to see than the front. It's the same thing. If you continue to cook. So you experiment with it, you will see what we're trying to explain. All right. All right, anybody else? Any other method? Would ever use any other method? Jeffrey, what method did you use? I'm not hearing you.
You bought the same way.
Okay.
Can you hear me now?
I'm hearing you.
The connection is a bit bad. I was saying using the geoboard the same way. I'll probably make them use elastic bands and thumbtacks and pin up a pentagon, and then I'll have them probably draw lines to form triangles and check how many triangles they form. Then they know that one triangle, the sum of all the angles add up to 180. So therefore, if you check how many triangles you can form from that pentagon, there are 3, and if you add 180 3 times, you'll get 540.
Very good. That's one method. Good. Any other method? Any other method? All right, come Ingrid or so moving on to part 2. Carlene and just ask Anna. I can't answer again. It's Anna or Zana. Just ask Zana. Anya? Where are my students? Caroline?
I'm here. Anya is there.
Okay. So where am I other? Where's Tasha?
It's just that my desk is away from my computer, so I have to walk over to unmute it when I'm on the desk.
Okay. Yes. So we're doing part 2?
Okay, for part 2, to help the students derive the formula, I would start with the simplest polygon, which is a triangle. So here's my triangle. And we already know that the triangle has 3 sides. Of course, it's one triangle. And we also know that the sum of the angles in the triangle is 180. Right? So this is 180 degrees. Okay, then we could move on to, for example, a square or any other quadrilateral. It doesn't have to be a square. Any quadrilateral. And if we divide up this quadrilateral into triangles, well, the smallest number of triangles we can get, not the maximum. Then we realize that this has 4 sides, and I can divide it into 2 triangles.
Okay, this is the method. Oh,
then we can, yeah, I remember. Then if we go to the pentagon, just draw a pentagon. We realize we can divide the pentagon as we did for number 1 into 3 triangles. So it has 5 sides, and there are 3 triangles. So we can see a pattern. In each case, we notice that the difference between the number of sides and the number of triangles formed is 2. 3 minus 1, 2, etc. So we can use that pattern because we know that there are 180 degrees in a triangle to derive the formula for the sum of interior angles of any polygon. So we can tell them let n be number of sides.
It's always number of sides. You should have like probably I would put another column. I would add another column here to say 180 and see that pattern also, so you can see that you're adding. You understand how you get that 180 idea? Yes, I would add another. I would keep having that to say some of it. She said it, okay, but I'm saying for students, you want them to be able to see.
So for this one, it's what?
360.
So you want to write 180 times?
If you can do that too, you could do that too.
4 minus 2. Huh? 80 times 4 minus 2.
Yes, and we can continue.
What's this one?
180 times 3.
80 times 3.
Oh,
so you
said
180 times 5 is in 5.
Number of times.
Oh, you could have a formula now.
Yes.
Oh yeah, so I just wanted to see the relationship between the different things. Yeah.
All right, so what's next?
So n is a number of sides. So if I want to find the number of sides of a polygon, n, and there's a known one called as n. But what do you notice there? You're always doing what?
The difference between the number of sides
so that's what I mean.
and the number of triangles is always 2.
All right, so write that down.
I forgot, I'm sorry. I forgot what I wrote. I'm falling asleep, but we're already. I just fell asleep a while ago.
Oh, yes. Because I'm trying to figure out what you said. Oh, you just said it, so I'm like, all right, so write that one down. So fun. Anyhow. All right, guys, are we getting the whole idea? Are we seeing the
Yes,
pattern?
we are. Yes.
Okay.
Yes.
On to the 180.
Yeah.
What's on to the 180 part? What do you notice about the 180?
So we notice that this number here is always n minus 2. 2 here is always n minus 2. The number of sides minus 2. The number of triangles. Right? So we can write that the sum of the interior angles must be equal to the.
I'll see you next semester if I teach the course. Why you want to come back?
Minus the number of triangles, which should be 180 into n minus 2.
Why would you come back?
Okay? Everybody has that?
Thank you.
You're welcome.
All right, guys. All right.
Thank you.
Okay. So, guys, everybody, are we seeing the pattern?
Yeah.
All right.
Yes, we are.
Yes, we are.
Okay, now, this is the last class, so I have to send you on 10 minutes early. Please go home, and we didn't get a chance to explore virtual manipulatives, but go online and kind of look it up. All right, and please make them a part of your class. I hope that summer 2, you can tell me something about virtual manipulative. All right, it was really nice getting to know all of you, and I'm trying to take vacation, so I'll try to figure out whose house I can stay. So,
Mrs. McCarthy, on behalf of the St. Lucian students, I would like to say thank you. We found your class was very interesting, very interactive, very informative. And yes, if you want to come to St. Lucia, you can call. You have our number, so you can save it. You can call or always WhatsApp. You can see. I'm sure nobody would turn you down.
how nice! But it was really nice knowing you guys. It was really nice working with you guys.
Thank you. You too.
You guys have done very well. So I'll see you in summer 2. Please enjoy the 15 minutes that I just gave to you. All right?
Oh, we have an assignment due, so we'll be working on that.
Okay.
Yeah.
All right, guys. We'll talk.
Okay, bye from Dominica.
Bye, bye, Dominica.
Okay.
Hi guys, bye. Thank you very much. Yes, ice cream, no,
Ice one ice cream. One ice cream, one drink. It's such a good fun. I think she